Ну что, друзья, добрый день.
Okay, friends. Hello, my name is Ekaterina Verso. I'm HR director of
Итак, первый доклад.
company, and today I'll be hosting this room.
Начинаем. На всякий случай напоминаю. Сегодня
So the presentation has already started, but we're only starting this room. I'm sure that in the chat feeds everything is quite fine, but who has a working day today?
потому что вас там будут
Please switch your working chats off, because they will be asking you different questions, and the real excitement is here. So you've come here, that's very good, and I suggest that you delve into the speakers' presentations.
живых выступлениях.
I think the best thing about these live presentations is questions. And please note, in order to ask a question, you'll need to use the microphone. The microphones here are in the aisles on the left and on the right of the room. So in order to ask a question, please come up to the microphones, and the speakers will be able to answer you. And now I'd like to tell you that this track has been prepared with the support of Posidev, this community of IT people who create high-quality software. And that's great. Thank them very much. And now I'd like to invite the first speaker to the stage, Alexander Polomodov, CTO T-Bank. Welcome, Alexander.
Добрый день всем.
Hello, everyone.
Именно в этом зале
It's nice to see you
что-то происходит.
in the stage. I'm sure that something exciting is happening in other rooms as well. But we are going to talk about whether reliability and security are some additional options, as some customers believe, and sometimes even engineers and developers, or it's an imminent quality of systems in our mad world. My name is Alexander. I work in T-Bank. I've been working there for more than 8 years. I'm now CTO of a unit involving 1,000 engineers. I
Я не настоящий безопасник, но вроде
I'm not a real security guy, but it looks like I get a handle on security,
который
and
внутри.
I try to make our internal systems safe by reviewing these solutions. So what we're going to talk about? First, I'll speak a bit about how this problem looks for myself, why I suggested I speak on this topic when they invited me to speak at this conference. So we'll discuss some key concepts,
Поговорим
the best practices,
компаний западных.
talk about cases from a Western big tech company. I'll share a bit how these things work in our bank. And then I'll talk a little bit about recommendations,
Это вам нужно. И
how it would make sense for you to do it. And in conclusions, I'll make some conclusions
чтобы что-то у
and share some steps that you might make if you want to make things better. And if we have enough time, I'll also be able to field some questions. So let's start by discussing how you can frame the problem. You can actually frame it based on the statistic that your company has, but if you don't have statistic, quite often you need to show some numbers. Security people like scaring managers. We're talking about the cost of data leaks.
5 миллионов
There's a research in IBM that an average cost of one leak is about $5 million. There's also an interesting poll
90%
about downtime
долларов.
that costs more than $300,000 for most companies. And it's not about some cascade type critical downtimes. It's just an average value. What does it result in? Your customers may lose trust in you. Your reputation will suffer. And talking about ourselves,
Доверие
for us as a financial organization, the trust of our customers is one of the most important assets.
прийти регуляторы.
And also, regulators can come to you and give you a meeting. So you have to account for problems that you may have. with downtime or data leaks. It's also an important part.
Таких данных, но ты нет.
And if you don't have some statistical data of your own, you can use some benchmark data.
А почему сейчас
But these numbers have always been there. Why do you need to think about reliability and security right now as a foundation?
развивалось? То есть
Actually, if you take a look at how the industry has been developing, it's
гораздо более сложно
clear that now we've moved to a much more sophisticated system.
в каком-то мульти.
We work in some multi-cloud mode. We have some installations in data centers.
которые в облаках крутятся.
There are workloads that are running in the cloud.
Начался бум
10 years ago,
все наплодились.
we started a microservices boom. Everybody started to build distributed infrastructure and basically shifted all this complexity to the operation center.
Интернет вещей,
We have IoT,
мы реальность
the Internet of Things.
связать.
It's where we try to bring together real things and storage.
Ну, поверхность атаки, она становится какой-то,
And the attack surface is becoming super large.
ну, как бы,
The picture here shows a graph,
в одном блоге рассказывал про их внедрение микросервисной архитектуры.
and it was
Jagger.
it's a graph from the Jaeger tracking systems. There's a similar crazy graph that you won't be able to wrap your head around.
Которые мы
So why am I showing you this? The complexity of the systems that we're creating
чрезмерные,
is becoming
размышлять,
overly
ну, вот
sophisticated,
буквально несколько движущих.
and
Вот.
you can no longer live in a world where you had just a few moving parts and the infrastructure was quite clear.
Нас ждет большой
And it's all determined by the fact that
набирать
in the high-speed business it's difficult to acquire new people,
и фичи.
to develop. So you have to develop your services autonomously, and you end up with this kind of landscape.
Угрозы для
And if you take a look at how
видно, что
things look,
страшно жить, короче.
you can see that life is becoming scary.
И, ну, попытаться защитить вот такую комплексную
And trying to secure such a sophisticated system post factum is becoming quite unrealistic. That's exactly what I'd like to talk to you about today. And I suggest
разных компаний.
that we'll be talking based on different cases. There's a cool research paper from Google people
Свойства
who
качества
were talking about
подкачивания
the quality of software.
понимали
By the quality, they understood
в их модельке,
a lot of things.
так, что есть внутренний
And the model looked like this. So there are some inherent qualities of a product that you develop. It's an engineering point of view.
то есть это как
So what's happening inside, under the hood? It's a process.
это как какие атрибуты качества в итоге,
And
которые вы создаете,
then you get the quality attributes.
поддерживать, развивать.
So the whole story is about how easy it is to support them, to develop them, how complex they are, how testable they are. And there are external aspects, the external
Снаружи.
qualities that people from the outside see. What do they see from the outside? They see how usable the product is for the customers,
Хороший user experience,
how good user experience is, how it impacts the brand, the sales. So it's like a product-based vision.
системы, которые
And there are some architectural characteristics of the system that
то есть все
reflect on the outside. So the story about the reliability. Everybody sees you as a black box, which actually consists of a lot of different boxes inside, but they don't see them. And so
начнут об этом.
if something happens to this black box, everybody will start complaining. It will be discussed in the media.
Разнообразные security проблемы иногда приводят к тому, что
And some security problems,
могут не работать там недели.
all sorts of security problems may lead to
Проникновение.
disruptions in the operation of companies and their business. The whole logic
Как раз была про то, что
of this paper was
штуки, вот эти
exactly about these
внимание
external properties being in the focus of everyone's attention, so everybody wanting everything to be safe and sound, the experience should be good, so the sales should go very well. But in order to make sure that this happens, you need to take care of the internal properties. So myself, as an architecture person, I hear quite often that you need to choose the right architecture, and then everything will be right. The problem is that it's easy done, and the guys don't, lose their time on metrics. So code quality, I translated as architecture quality, but they said it's cool to work at the level of process, to make processes such that you get a cool product. That reminded me on the 9000, ISO 9000 story, when you want to have sausage of high quality, you start, building processes on the factory, ending up in the product quality to be good. So this approach is about the emergent properties. It's the property that our system gets that is not really a mechanical sum of separate properties within. It's an effect that happens at a system level, and security and safety are really about this. So we need to look at our entire system design, the process design, so that these emerging properties should really happen. I am showing Mandelbrot's fractals here as an illustration. The story is very similar. It looks like it's a simple object, but it has very surprising properties. And so there's a very simple function that describes these properties. So as a result, what we're getting, if we're talking about reliability by design, and in our industry there are certain practices, site reliability engineering, it's about design of systems, considering that downtime will happen if we need redundancy, if we need fault tolerance at the low level, so that our systems should withstand that. And in fact, quite a lot has been done here. All the different approaches to do that have been popularized for like 20 years or so. We have a case of our own engineers in our bank, and they're doing this, and not only them. But as a result, reliability gets engendered into the development process. A similar thing is happening with security. When everybody was talking about DevOps, then they started adding some other words in that formula, resulting in DevSecOps, DataOps, Domain Ops. So we're interested in DevSecOps when we're trying to embed security into our development pipeline. And I am very fond of all these DevSec, data, many and other things of ops, because you tend to lose, and I speak ironically, because you tend to lose the essence behind all these beautiful names. In that aspect, Google's approach calls for interest. They have this secure by design approach. Here's the very essence of it, what they're talking about. They're saying that there's a point where we're just writing the code and it's not yet part of our main branch. We haven't yet finished working on the code, and then it gets there, it's deployed, and now it's deployed in production. What's the essence? The essence is that, according to them, you need to focus on this. You have to shift everything left, so the shift left, the new term, and you need to embed security before the code has got into the final branch, when you're still designing it. Now,
заняты.
roughly speaking, do that when you're still actively developing it.
Делать
Actually, they're proposing that this should be done through
что
deploying a safe developer ecosystem.
про то, что
So with safe coding on the left,
ну, вот, их подход предполагает,
so
что
their approach proposes
внутри
that
экосистемы у вас
in this ecosystem,
многие практики
you have a lot of practices integrated into the process
какие-то. То есть
in the shape of some libraries or components. It's not expected
знает
that a developer
безопасность. Но а
knows everything about security.
граблю там.
So,
Вот. И остальное. Соответственно, второй кубик,
So-
который они говорят про
the second box that they're talking about,
куда-то уезжать, да, то есть это история
the code needs to go somewhere at this level.
м,
So, this story is about how they make sure
рантайма, куда уезжает, у вас некоторые security
that
должны быть контролировать
all the options that you've taken are controlled at the control plane level.
Zero Trust.
Security people will start talking about the zero trust approach here.
Некоторая история, когда вы уже не на уровне
It's some story
разделить ваши
when you're trying to share your workloads at a deeper level than at the network.
что вы
And
понимаете,
the last thing that they're talking about is about a situation where we understand what kind of workloads exist in your organization. For instance, there are web services on the client side,
базы данных. Вы можете
and there's a database, and you can use,
ну,
remove some standard vulnerabilities.
нужны для
Not all of them, but at least those that you need for your specific apps.
приложения уже
So the patterns of these apps, to make sure that the patterns of these apps should not contain these simple vulnerabilities. It's all very good, all these approaches, but the question is how
и
it can be taken care of at the design, at the development level.
я отвечал, ну,
And let me just share. It so happened that
по системе дизайна у нас внутри компании
I was responsible for some time for interviews in our companies. And the way the interviews were looking, we were verifying the skills of design engineers. We're giving them simplified systems. We offered them a set of business requirements from which they could understand what scenarios, functional scenarios would be needed. We told them about the quality attributes. And then we were looking at how the person was taking account of these things in the design process, how they will collect all these requirements, functional or non-functional, connect them with one another, understand the priorities. And this reminded an approach that Software Engineering Institute came up with in Carnegie Mellon University, invented about 20 years ago. They called it Architecture Trade-off Analysis Method, ATAM. Actually, this method described a very similar story. So you have some business drivers, you have a scenario. In these scenarios, you have some quality attributes, for instance, some performance parameters expected, or some basic security, or that it should be able to scale up under load. Then you compare these different quality attributes, understand what's important, what's less important, and you make a decision. So it's kind of a weighted approach to design. But this system design doesn't have anything about security. And I started noticing that, in fact, in the design of solutions within the company following this process, they take the shape of architecture decision records, where you explain what we do and why, functionally, but nothing is said about security. And then guys from security come to you, see the solution, and ask you why you haven't thought about it. Actually, it turns out you can do it differently. I forgot to mention that, in principle, the set of trade-offs that you use
И вы можете, ну, на самом деле, выписать еще риски, которые...
you can actually
Вот. И, ну, как-то их отприоритизировать, чтобы...
take care of the risks that your system is exposed to when developing those.
Процессу, про который я говорил.
So coming back to the process that I started talking about, it seems that it would be much better to make it so that the people who play the role of an architect, I mean the engineers, so that they could
Делать
understand what the system should be able to do business-wise and what things it shouldn't contain, I mean, in terms of threats.
Если бы мы могли это добавить, я думаю, было бы хорошо. Вот, потому что, ну, я вот вижу бутылочное горлышко зачастую во всяких security аудитах в том, что тебя спрашивают про архитектурные диаграммы, описание, еще что-то, а потом
And there is a description,
и так не хватающие,
and it lacks.
так скажем, наверное, не недоставленные, то есть инженеры безопасности, которые перегружены, они пытаются...
So the security engineers,
Можно поиметь.
they are trying to switch from the architecture
Дальше пойти и сами подумать об этом.
and to go further.
Окей, но давайте немного там...
So
Я расскажу про там, то, как
I promised that I would
подходят к
tell you about big tech companies' approach
безопасности, потом немного
to the security and reliability,
девелопера
and then
делается.
how we work it in, how we make it in our ecosystem.
Дефолта. То есть Google,
So let's start with default. Google,
то есть
reliability at scale,
SRE, история с loss lead
popularizing
всем остальным,
SRE
SRE команда,
and SLO. There is a dedicated SRE team of engineers and developers that you make to automate operations. Not everyone can allow this,
интересно,
but it works fine.
достаточно хорошо.
And as to reliability, it's
У Google есть
quite popular. There is also design review.
к этому выступлению.
In a post that I've made on this presentation, there is a link on my channel. I was writing how they were improving their design review, how a process looks like.
задачи ревьюет
So upfront, before the launch,
при выкладке.
as to analyzing some features.
И, собственно, история какая, что
So the story is
у ребят получается
that the guys,
сервисы, которые ну, на
they
масштабе
have quite reliable service,
я показывал
which works fine.
про комплекс систем, там картинку
Remember, I showed the
тоже.
complex systems, and the same is on Flip.
16
Like 10 years ago, from 2016,
сервисов между собой
when there is a graph reliability of services,
достаточно в интересном
and Netflix went further
этого решения.
by providing reliability,
Вот как House Engineer
and they applied chaos engineering approach,
компаниями, ну,
which has been already adopted by some companies, even on Russian
архитектурная
market,
где
like Yandex Taxi guys at the architecture conference.
House.
They were
Но
presenting how they have tested something using chaos, something inside Yandex Taxi, and they are still living in OS,
в принципе, это
and they have a lot of services.
очень сложно.
So to assess the reliability of services is quite difficult. So that's why they have a list where they do
насколько они хорошо
failure injection
чувствуют, да, после
inside their system, and
проблем. Вот.
they look how they behave after such problems.
На самом деле,
So this started with Chaos Monkey,
ну,
and then
менялись. Вот.
the tools have became even more complicated.
В рамках Netflix есть подход про
Within Netflix, there is approach
которые сами
as
отвечают
to stack a team,
и
the engineers who are responsible
то есть, насколько я
for operations,
такой, ну, по крайней мере, раньше SRE команды не было, может, сейчас она есть,
and
но
SRE team was not available. It's available now, but when you are always checked in action,
в своих решений,
you are trying to
что
accommodate
будут даже не
those failures in your design, even not because of hardware or infrastructure services,
сеть,
but
центр,
there might be a data center failure or power failure.
Рассчитывать на это, если ты знаешь, что это точно
So
с определенной.
you should accommodate it if it happens from time to time.
Есть АВС с тем
And there are also
понимаемым тезисом
events.
security.
There is a
Вот, ну и про то,
thesis that security is our job
в общем и целом
and that you build it around,
пытаются security
but they're also trying to return security to the teams
в принципе, ну,
and saying that
устроено by default в
it should be
делается. Ну и
built by default into the services
тоже есть
that are carried out.
для условных
We have different types of reports for the top managers
безопасности
about reliability
продуктов,
uh,
сервисов. Короче,
and
когда ты знаешь, что это на радарах,
safety.
в принципе,
So when you know that it's on the manager's radar, that motivates you to consider all this issue.
а как у нас-то, да, то есть как мы с этим живем, вот.
So how do we live with this?
Живем мы приблизительно так, то есть с 2020 года мы от такой
Since 2020,
инфраструктуры,
from
там, команд и отдельных продуктов начали двигаться в сторону нашей
separated teamwork,
платформы разработки,
we
платформы as a service,
we moved to this internal
есть
development
странички,
platform.
где они описывают
So where the guys have their web page where they describe their principles, how they develop their platform for the engineers,
эксплуатации
for everyone who is involved in code creation and
жизненного цикла.
operation. There is responsibility and transparency
Вот эти
of the life cycle
оценки качества,
of the code,
ну,
and the quality assessment.
не только вот
Quality assessment is quite wide.
воспринимать
It not only applies to testing.
этапы этого жизненного цикла
Of course, you won't be able to
на каждом этапе. Есть
go through each
идеологический
stage,
мы
but there is an ideological approach that when we've moved from the old decision,
сделали
from the bit backend,
все
Bitbucket,
ну, и
all defaults are open,
усилия для того, чтобы его закрыть. Ну и суть как раз в том, чтобы ты мог найти,
and you would apply 3 actions,
законтрибьютить туда. То есть, желание такое было, не везде.
and you would need to contribute at that time.
Контрибьют соседу, но там технические возможности есть. И вот эта
So technically, there are some opportunities
платформа
to.
фокусируется на результате, и под результатом, кажется,
The platform is outcome oriented,
на снижение
and the result means that
для
it's to decrease cognitive complexity for the engineers,
инженера,
because it's difficult
который
to
знает,
be an engineer
например, то, как работать с требованиями,
who knows how to work with requirements, with certain
и так далее. То есть реально
systems, with
на глубоком уровне, чтобы end-to-end там спроектировать что-то.
security. So it's difficult to have all this knowledge on the deep level if you are designing some M2M.
Рассчитывать можешь.
And if it's built,
Инженер
factory pre-built
легко идти
somewhere,
то
then
есть
it's easy to.
сделать как-то криво, да, а правильно сделать хорошо.
So
Инструменты абсолютно
it's easier to do it right.
достигли
I cannot say that we have all the tools right,
но
or that we have
туда идем.
reached environment.
И эта
In
платформа, она вот приблизительно так выглядит. То есть
so this platform looks like this. There is a portal,
API-шки, причем
online interface, AP,
самые продвинутые в компании. То есть,
and as to AP management, the guys are most advanced because API management
пользователи в кастомере
for the
или даже B2B направленные не такие
customers,
продвинутые.
because sometimes B2B.
Менеджмента, ну, процессного. То есть у нас есть Jira, Wiki, там, инструменты для коллаборативной работы.
So there are
приложений. У нас есть
catalogs of apps for collaboration
нужное изучение, то есть
and
внутренний поиск,
some documentation, internal search
коду, автогенерированной документации,
for
Wiki
the
и так далее.
whole code, auto-generated
Ребята
documentation, wiki, jar.
достаточно
So this search is quite quite smart.
доступны. Вот. Ну и VDE-шки
VDI, which is accessible.
где они по большей части
There is a platform engineering night where the guys were talking about Nestor,
Дело история про
our co-pilot.
разработку и build инфраструктуру, то есть вот здесь
Also, it's about developing and build CI, build infra, templates, secrets.
есть большая часть про, собственно, раскатку. То есть ребята взяли куб вела и идут 100
So guys bought a
повыше дать над, ну, над кубом, как централизованный рантаймом. Есть
So it's like a long-time centralized solution.
database as a service, есть
It's delivering rollouts as a deploy as a service,
работа с артефактами. Вот.
DBA,
На самом деле в эту PaaS
working with artifacts.
вообще под этим лежит
So a lot is contributed to this phase.
облака, то есть про
It's like self-voice. I was talking about the cloud, like multi-cloud or hybrid cloud.
много железа, тебе нужно ему
So when you have a lot of hardware and you need to manage it, where there is a issue of capacity management and a la FinOps approaches,
compliance,
there is a security approach,
и управление трафиком. Ну и есть вот эта
and there is also
история вокруг
traffic information.
и тоже безопасности.
So this is a story about reliability and security,
Платформа, в которой все живут.
because we have a
Логи, методы,
serviceability program, platform, common for all,
менеджмента.
and there is a system for incident management,
Вот. И
which I'm going to present later.
набор инструментов как раз для контроля
And there is a set of tools
разных этапов.
that provide for quality at different
Вот как раз
topics of
observability платформа.
CDLC.
Это был
If we talk about observability
начали с плана.
program,
Еще до того,
we started to
стало популярным, то есть это Sage, мы его продаем,
sell Sage.
пользуется этой историей. Ну и это очень удобно, когда все же
This is quite convenient when everybody lives on one observability platform.
очень легко выстраивать. То есть ребята поверх этой observability
In that case, it's quite easy to
инструмент, который позволяет, ну,
restore.
как что-то не так
And there is some
в твоей экосистеме.
instrument which allows you to see
Вот такие кубики, то есть ты можешь завести
and
команды и на самом деле их там
in the
между другом.
service you may rename the
В итоге есть
team commands,
детекция инцидентов.
and like there is a
Платформ,
solar from detection of instruments.
сло, там сла по твоим системам, и если они пробиваются, заводятся инциденты, ты можешь, у тебя есть жизненный цикл инцидента, то есть
So you have the incident life cycle.
это делать, например,
You may do something with it.
подтвердить, что инцидент наступил, или
You can confirm that the incident has happened.
там, критичность.
You may decrease its criticality.
Этот инструмент на самом деле завязаны наши процессы вокруг надежности.
So the processes are around
Ты можешь
reliability, some failures. You may subscribe to some interesting events and build an escalation curve.
сначала команду,
With an incident, you have first the team, then it's escalated to the technical director, then to the whole team. If it's too big,
история про вот эту
there is also a history
инцидентов, постмортем,
of analysis.
culture, так называемая, да, то есть когда ты,
When the culture was blamed,
причина инцидента, и потом
when you understand what was the reason of the incident, and then you describe how to prevent it next time, there is analytics.
я говорил про разные виды отчетов, ну, собственно,
There
отчет,
are different types of
то есть на уровень команды, там, директора какого-то блока, или на уровень
director of a block or the whole company.
вот.
And there you can also manage releases,
Да что такое-то? Видеть, насколько релизы коррелируют со сбором.
and you may see whether the releases are correlating with the share.
Со сбоями.
So we are thinking about the share of
А-ля Copilot внутри наших IDE-шек, вот, а внутри Copilot
in IDEA.
широкая новость.
There are like copilots, and also there is a good news about IDE
То есть он и в пайплайн встроен, и в этот
in
источник, потому что у тебя некоторая
inside the pipeline, and in
предлагает тебе
VDE,
уязвимость.
the model finds vulnerability and suggests some changes.
На простых кейсах работает хорошо, на сложных
So it works well on simple cases, not so well on complicated cases, but this can be tuned because it's inside necessary
Ну, то есть наши, условно,
etaps of pipeline. So our
и смотреть
security
использование как раз
may watch over and look at the usage metrics. They don't have to make any efforts to force somebody to use it, because the improvement would become better and people would be gladly smoking. When there is a good platform for different engineers, you need to understand how to promote it, how to develop it, because there are different approaches to developer experience changes. So my colleagues adopted DivX first. So you need to understand how the cognitive load looks for the engineers and the reverse links and ties, whether they can work without those limits.
Они рассказывали на нашей конференции Platform Engineering Night.
So they were talking about our conference in Geneva.
Как это работает, про как они снижают когнитивную нагрузку.
So how do they lower cognitive?
Computer Foundation, в котором, ну, как бы,
And it's the
разобраться про как раз про то, что
Computer Foundation where very few can master this.
и понимали, что
They have measured lead time and they understand that there are
быстро поставить.
issues which prevents you from
Ты хотел их
hold-
сократить, да, то есть сжать, выкинуть часть этапов. Ну и, собственно,
So you've tried to
которые позволяют
shorten this, to get rid of some sites.
которые ребята мерили с
And since the
метрика с 2021 года
this metrics is from 2021, when the platform was still developing.
до первого merge request, до мерджа
So
основную ветку. Вот видите, все драматически падает. Вот.
everything is falling dramatically.
Средняя продолжительность мэра тоже вот эти красные столбики, это, по-моему, январь. Ну, короче говоря, или там декабрь, ну,
So it's January, December.
ну, и
It's the vacation time. That means that people were saving several years. So from developer experience, they come to a stronger, more complex methodology and space. And with other approaches, a colleague of mine who
хотел, ну,
is responsible at CityConf
мы измеряем.
Pro
То есть Space — это
DAFLAV.
фреймворк, который меряет
So XSpace is a measure which
какие-то
measures not only
и, например,
activities,
например,
but you can also find some perception like satisfaction, well-being.
то, как
1-minute story about performance, about how to communicate with the team, and whether it's efficient, and whether the people are in the state of.
Например, у нас есть вот эти, помните, я говорил, что касты инженеров, самые большие — это, собственно, разработчики.
So the biggest cast are engineers, those that develop and test
Меньше всего,
CCR.
потому что они больше всего сталкиваются с проблемами на проде, ну, вот, ну, с реальными. Там просыпаются, реагируют на инциденты, еще,
So they can wake up, react to an accident,
которые там
but in other cases,
кода мы меньше смотрим, так что ну, тут
they look at less code
в общем и целом
and they are more happy.
подход. И
But in general, it's an interesting approach,
в платформе, ну, не
and the editor on the platform,
используют ее
they collect a lot of information and use it to improve the tools,
нашим инженерам.
which improves life for our engineers in turn.
Давайте немного поговорю
So I've discussed about this. What about our recommendations?
кого-то в чем-то убедить или как-то выставить эту работу. То есть
So to persuade someone or to do this job ourselves.
на каких ролях находится надежность и безопасность, это, ну,
So what about business and reliability in this?
огонь. Куда нажать? Окей. Переключилась. Собственно, как сделать, да, это?
So how to do this?
Надежность и
How to
безопасность
achieve it?
каким-то приоритетом.
Reliability and security be a priority.
Как бы топ-менеджеры это включили в
It's important that top manager would include this
и
into some of their
у
vision,
нас так было.
where the key trend would be.
Года надежности, когда там у всех технических директоров была задача там добиться определенных, ну, типа, показателей.
The task was to
в начале года
reach certain indicators.
делается отчет, как мы меряем, методология.
So we make a measurement, we discuss methodology.
Сначала
In the first quarter, if you need to polish this,
сделать так, чтобы вот те метрики, которые рассчитываются окей,
so it's
ну как бы их начать там поднимать, в четвертом уже там
you can
вот.
raise it and make some,
История была. Они пошли приблизительно в такую же историю с моделью там зрелости, с
give some result.
отчетами, но
So they went into different metrics and reports, but without this vision that it's important for us, it won't happen. So the vision give birth to the goals that come to VKR or a different planning system that you are installing. So if the goals are there, but there are no resources, nothing would happen.
Ну, зачастую у технических директоров была задача объяснить
For those technical,
Перу, там, бизнесовому директору, там, почему это влияет на бизнес.
like explain why it impacts the business, how it impacts business, how much the failure would cost. Explain this to your technical director or team lead, and to agree for some quota of engineers.
Даже появилась некоторая а-ля размер
And I would say that after that we have a
ну, как бы ресурсов.
time exchange.
Новые задачи, сколько
You see how many time it takes for the
миграции,
business tasks.
вот, или импортозамещения, или там еще что-то. Ну, то есть ты видишь, как твои
So when you see that
по-разному.
your resources are
Ну, и, собственно,
packaged into different
нужно это, ну, пересматривать
bags,
со времени.
and the risk management should be also
Иногда
revised because risks change as time passes.
дальше есть
Because some people are trying to achieve the task which was already passed, already gone.
тестировщик. Ну, собственно,
So
за качество
those who test, they're responsible for the
какой-то человек
quality.
отвечает конкретный, да, там. Но на самом деле мы, как уже поняли, это общая работа. Ну,
But as far as I understand, this is common work, common result.
общая. Вот. У людей должно быть понимание, что они могут на что-то влиять. Ну, самое грустное, что может быть, когда тебе говорят, ты отвечаешь за это, но будешь делать бизнес-задачи. Вот.
When they say that you are responsible for this, but you will have to do the business task as well, and then you're saying that I'm willing to do this,
Ну, типа,
but whether this is increases reliability or security, and I'm not allowed to. Like Blameless says,
ошибки какие-то, ну, то есть проблемы с безопасностью, они будут всегда.
so they would always,
На это реагируют. Достается ли там кому-то по шапке за это, или ну, вы
whether there are,
учитываете эту проблему и пытаетесь ее предотвратить в будущем.
but you are trying to prevent this problem in the future. I discussed about architecture
На этом этапе мы должны учитывать вопрос
so that we could
архитектурных характеристик, там, надежности.
have in mind these issues of architecture and reliability and security,
Достаточно там, понятный.
that we need to apply some
Ребята из Гугла замиксовали как раз надежность и безопасность, и написали прям набор дизайн-принципов с примерами.
so like a set of design principles with examples
Там,
that you could give.
говорит, что вот очень неплохо описаны там принципы, которым нужно следовать. Да, есть фреймворки и стандарты, вот, есть моделирование угроз, все это хорошо бы делать.
There is
Вот эту историю
threat modeling
и интеграция в
and shift left integration.
то есть, в принципе, тут тоже никакого rocket science нет. В принципе, просто нужно этим заниматься. Ну и, собственно, какие проблемы часто бывают?
So what are the problems that we often see? Sometimes it's
Там будет счастье, но
perceived as a one-time project,
история долговременная.
but actually it's a long-term story where you would have to always tune it.
Как бы не обращают внимания на там, человеческий фактор. Я конкретно часто замечаю, когда я
So I understand that
ходишь, говоришь, окей, как вы это делаете? Говорят, мы на Вики написали. Вот, все должны прочитать и делать это.
that everyone should read this
Но как бы
like
люди совершают ошибки.
it doesn't work like this because people make mistakes and any wish
Это
which is not approved by tooling by
скорее
VIT
всего никто не прочтет. Вот, а даже если прочтут,
and nobody is going to read it, but they won't be able to use
можно смазать.
zero.
Вот, важно не делать так, чтобы эти команды надежности и безопасности жили где-то отдельно на своей.
So I don't want this to live somewhere
важно обращать внимание, что у вас как бы,
it's important to notice,
короче говоря,
to note
проблема начинается там,
that the problem often starts little by little, and you may say that this is
они накапливаются.
no worries, you don't have to do this, and then it
Про будущее, да, про
starts.
с нами. Ну, в принципе, он как бы помогает вроде, но одновременно генерит новые
So it helps, but at the same time it generates new threats
наш
or new hazards. Our system becomes more.
подход, то есть архитектура. Очень любят про него говорить, но это достаточно.
So they like to talk about this, but it's quite a difficult thing, quite expensive.
В эту сторону часто лежат, по крайней мере, на слова говорят, что мы туда идем. Вот.
So they would often have to.
В ту сторону лежат. Да, инфраструктура усложняется, регулятор известует, вот, и часть систем у вас теперь не только
And some systems, they are not virtual, but also in the real world.
когда-то
There are cash machines.
Физическая защита наших офисов, как она спроектирована, тоже было очень интересно смотреть, как это интегрировано между собой. Ну,
So it was interesting to see how both offices were integrated. And the question
основные свойства, то есть их игнорировать
is about the fixed assets. We cannot ignore them.
надо холистически на систему.
And then we need holistic systems
Ну, по-другому не получится добиться каких-то,
because it won't happen otherwise.
нужно у лучших. Вот, лучшие
We need to improve our work.
делятся своими подходами, практиками, фреймворками, инструментами. Вот. Можно брать, использовать.
So you may take and use it.
Разговаривать и
You need to act and not just discuss and constantly improve yourself.
постепенно до своих
So the thought could be
партнеров, да, то есть со стороны бизнеса, что ну, это не такой блокер или там инвестиция.
so. This is not a blocker or investment in nowhere. It's a way for us not to become, not to stay in the moment, but be reliable and have conditions that allows us
Наступит какой-то момент,
to.
мы условно превращаемся в банкротов. Вот. Ну и, собственно, с чего можно
So
текущее
what can we start with is to assess current state,
где мы
to allocate some funds where we can get the quick wins,
цели, вот, инвестировать в тулинг, ну и дальше ставить планы и по нему двигаться. Ну,
and to make investment and to make plans.
успешных результатов, следующие шаги. Вот тут вот есть первая половинка обзора.
Here there is a first line on the.
Вторая будет, ну, условно, через час или два, как вот я дойду до спикерской и допишу. Вот. Там я достаточно часто, ну, и такие статьи пишу по выступлениям или обзоры разных материалов, ну, как я сегодня упоминал. А вот тут вот QR-код для, как я понял, для голосования за доклады, для оценки. Собственно, на этом все. Я могу...
So there is a voting for the reports and for assessment. That's it from me. I may answer your questions.
Итак, а перед тем, как мы перейдем к вопросам,
Before we have Q&A,
обязательно
I'd like to remind you
по ссылкам по QR
that please follow the links, QR codes, and you need to assess the presentations, and it's important both for the speakers and program committee. Among those that will be assessing
мы разыграем
presentations in Lovelace and Babbage, Lovelace,
Ну что,
amazing
вообще все говорят, что это круто, я еще не читала.
advantages of Lovelace and
Мы
Babbage.
переключаемся на слайд, там
This would be a gift present to those that
можно задавать
would ask the best question or participate in assessing the presentations.
Лучшие вопросы.
So please ask your
Мы подарим
questions through the microphone, and we would present a book from Peter
ребят. Если у вас есть
Publishing
вопросы,
House.
давайте подходите.
If you have any questions, please
Пожалуйста.
come up front to the microphone.
У меня скорее комментарий.
I have a comment.
Переход к практике.
When we were discussing transition into practice, you talked about
И
fixing on
хочу
current state.
обсудить принцип,
I'd like to discuss the principles,
как сказать, нулевой безопасности, так скажем.
principles of zero security.
Ранее говорилось про нулевое, ну, в Гугле как нулевое что-то там было. Я хочу сказать, что нулевой приоритет, да, вот я вспомнил.
there was
Что прежде чем переходить к оценке,
zero priority,
вернее, во
and
время,
before we moved
мне кажется, нужно хвалить
And
людей за то, что они уже участвуют в безопасности, потому что часто говорят, что
security already, because often they say
этого недостаточно.
that you have an antivirus, but that is not enough.
Используют какие-то линки,
So when they use some linters, it's not enough for the developers.
в компании был какой-то позитивный отзыв,
So in order to have some positive feedback,
говорить, что вот эти люди
you need to say that
попадаются на
those people are not
какие-то линтеры,
phishing prone. They are using some linters in development. So I'd like to share additionally to your
концептом,
presentation this concept
люди уже что-то делают ради
that people are now doing something,
качества.
their quality in the company.
Нету часто есть вопрос такой, что этого недостаточно.
Often there is a question that this is not enough, like there is no compromise between IT, HR,
Вот.
and
Вопросы, комментарии, если хотите, комментируйте такой вот.
security in this question.
Спасибо за комментарий.
Thank you for the comment.
Сейчас погружаемся
Well, actually, we're delving
change management, да, как это
into the area of change management to organize this. And this whole story
уже делают что-то в нужном направлении.
about people already doing something right should be commended. It doesn't take away the need for doing something and saying that the efforts that used to be optional are now becoming part of the mainstream.
Я рассматривал это с точки зрения,
So actually, it's more like
что делать. С точки
I was looking at it from the point of view of what needs to be done. We need to persuade people around you that it's important, that it's worth the effort. And quite often they ask you, so what's the problem? What don't you like the way it is now? And without some assessment of the current situation, you won't be able to do it. And then you play the role of a person who starts scaring other people. You're telling them, well,
говоря, да,
there's a 1, 2, 3, and then there's a neighbor
на неделю. Вот мы хотим,
whose situation
ну и дальше вот это чувство срочности создаешь.
got him into trouble. And then you start sharing what can be done, and then you get an opportunity of playing on those fears and expectations to show them what can be achieved. And quite often, if you spend some time doing something without achieving results, people don't expect anything from you. So people get used to the security people to first scare them.
Очень интересно, но у нас довольно
Well, I actually hate to interrupt you, but we have a very dense timing. Thank you all.
так это
I would just call for you guys. Could you please keep the time better? Alexander, thank you for the question. I'm Andrei from Yandex Cloud. I also have a question and a comment. You mentioned the shift left concept, that we want to start earlier at the design stage, thinking about security. There are different ways how to approach this. On the one hand, there are dedicated security people that we get involved with, so we get them involved earlier, involving them in test and tooling, but the expertise is not always there. So I fully support that. But there's a different approach that could be called start late. So it's not about shifting left, start left. So we just starting, building our own expertise in security even before the project. So here I'd like to ask you, how do you look at it? Was the balance, the right balance, where the line can be drawn? Maybe what kind of practices of that kind are using feedbacks? So there's a practice of security champions.
точно стартовало. Вот.
Well, we certainly started this, and I'm sure that
Ребята, условно,
dedicated security people
критичные продукты,
or
вот,
critical products,
а-ля security чемпион, там, первый,
like security champions,
типа, были, они,
we had them.
на самом деле, из
They've worked closely with CTO and his team, the high-level engineers,
проектные какие-то активности ведут, ну, в смысле,
who lead some cross-project activity as staff engineers. So they work through all these things together. But from what I know, we didn't cover all our products this way. And many products that were not that critical, it looked like you were getting a person from a shared pool who could review your solution. And quite often it happened quite late when you already had a prototype ready. And the problem here is such that one would want your internal people to model the threats. But such a thing as shift left, everything is happening, and security people coming to you saying that data needs to be changed. It would be nice if you knew what ML problems or models you have inside that, so that you have the skill of how to update it. They also tell you all the testing is your responsibility together with load testing. So, roughly speaking, you get a set of skills that goes beyond any limits. You would, have to develop these skills for 10 years or more. So basically, tooling should help you there. So if security guys don't have the time to come to you when they're needed, they could offer you some tools. So one would wish, of course, that there shouldn't be too many false positives. But because when you start crying wolf, people will tell you we're not going to listen to you. Well, there may be different approaches, and we'll try to confine them. So you want to shift left, but you don't want the brain of the developer to burst as well. So next question. Hello, Alexander. Thank you very much for your presentation. It was exciting. So my question is, in your presentation, you paid quite a lot of attention to everyone in the development team being responsible for the quality. All roles, all positions. So, are there any practical is there any practical advice, or practices, or techniques that you might recommend to build such a mindset in the team so that everybody should feel being responsible for the quality? Well, actually, the process should be comprehensive, starting with hiring. So we have the hiring process, and we don't hire if a person is saying that I would just like sitting in my corner writing codes, and I don't want to understand business. And so questions like about that are being asked at the hiring stage. And so, and when you're talking about a team and a product, if a person says, no, I don't want to be touched, I just like to write some code in that corner, then it's most likely not, this person is not going to be hired. Then once the person is already inside the company, it's important that they walk the talk. And in terms of promotion, it usually happens as a result of a certain process where you showcase the artifacts that you've created, and there's a set of tasks involved, and also feedback from your colleagues. And if the colleagues should say that the guy may have done something, but they don't really show any leadership traits, or not trying to get inside the process, then you will not get higher than, let's say, a middle-level professional. And also this whole story about the bonus compensation. One thing is when the person is pushing in such a way that they understand what the product is all about, the requirements, why we're doing that, why these architectural properties are important. So they're ready to invest in this product. Then they get one kind of compensation. And if they don't do that,
Соответственно,
then the time arrives where they just leave us.
делай это не на словах, а
So you have to do hiring right and also do reviewing right.
Теперь самое сложное.
Okay, thank you. And now the most difficult thing. All the questions were amazing, but you have to select one and will offer a book from the Peter Publishing House.
вот, типа,
So the first was a comment, the second was a question,
как это организовывать процессно.
how to organize the process, and the third was how to implement.
Мне кажется, что
Very difficult.
интереснее, почему
I believe that the third one was more exciting because it's easy to do the talking, but it's difficult to do it in practice.
только рассказывать,
So basically,
не делать,
if it's only about telling, speaking,
не
and not doing,
культурно внутри, не выстраивать
not popularizing this culture within the company,
то эти все разговоры останутся на бумаге. Что вы
hiring and promoting people, so all these things will send papers. So I'll award it for the last question. Last question. Okay, thank you all very much for your questions and to the speaker for your amazing performance. And my last request is for the winner to come up here and get the prize. Thank you.
Я готова пригласить на сцену
And I'm ready to invite the next speaker to the stage, Daniil Podolsky from Yadro.
Go Community.
He's an evangelist of the Go community. You're welcome. Your applause. Hello, colleagues. So, today, my presentation will be an attempt to make a technical, presentation failed because it still turned out to be a motivational speech. So today, I will be speaking about how we use and you could use code generation from Proto 3 declaration. So to start with, about myself, I'm Golang evangelist. I work in Yadro, in the operating system development, in the Common Platform group. The most infrastructure that may exist in the core. So we make sure that all our products function there. What kind of products you may have heard? Anything that you can find in a server room and a data center, we do all of that, from switches to servers to storage systems. The flagship storage product is totally unified, and it's fully built on gPC protocol that's described in Proto 3 format. And it's about code generation from the Proto 3 format we are going to talk about. So firstly, Proto 3. Colleagues, please raise your hands, those who know what it is. Excellent, great. And those who know Proto 3 extremely in the context of gRPC. Okay. There may be different options. It's very good that I'm here to talk about them. So there are some standard generators that generate different formats from Proto 3, and they don't do everything that we need. So we had to write a couple of our own. Of course, another thing, why this topic is important, because the modern-day programmer, a young professional, and I see that in young professionals, sometimes get an impression that everything has been written before us. So the only thing that a young person is left doing is, stamping CRUDs. And quite often, it's that what we ask them to do. Why? Because it's me who can say, let's find a student who would write simple CRUD. But it's quite a tedious task. Not too bad one or two times, but then you get bored. So what I'm going to talk about today is different. It's about infrastructure tasks. Infrastructure tasks are different every time. You never solve it the same way. And second time, they're much more amusing then simple things described in Proto 3, the described protocols. So I'll try to do without reading manuals aloud here today. Therefore, the final part of the presentation will be a little bit crumpled, but let's try and figure out. Now about the importance and the relevance of the task. We're in the common Yadro platform. We have about 10 different plugins. I counted them going through our configuration files. I can go through all of them. I was planning to go through all of them one by one, explaining why we need them, but I'm not going to do that for now. You can ask me later if you're interested. So what's important? There's a standard doc plugin that generates from Proto 3 documentation in the Markdown format. Why it's important? Is it important? Because we use Proto 3 as the main tool to make sure that information is exchanged between contiguous systems. Why do we use Proto 3? Because we want to formalize our communication with neighboring systems. Why is it so important? And I have a point of contact with the previous presentation because we need to keep the spread of complexity under control. So in order that our colleagues from the neighboring department should not be scared, we always need to provide information in a consistent way so that they, having looked at the documents that they get from us, could immediately say, what is where in this document. So this part is about the external interface, this part is about transport formats, this part is about output parameters, validators. So Proto 3 is a certain hypertext format. There are links, imports, and when you read Proto 3, you quite often have to look into the neighboring files and the library files. There are clear links there. But these links and references are not automated. So you don't have an extension for a browser, you don't have an extension for a website that could show Proto 3 in such a way that you could use these links. So therefore, we use the doc plugin that generates Markdown with links. And as a result, our Proto 3, without any external changes, turns out to be presented as a navigation convenient tool. It's one of the most useful plugins that we wrote. Why we felt a need to rewrite it? Because for some other protocols we needed Markdown templates a little bit different, and in order to add Markdown, we had to get into the source code of doc generation, and it's written. They're written in Go, so it was an easy job. We managed to do that successfully. And the next plugin that we needed to rewrite, it wasn't written in Go. It was Python gRPC. It's a plugin generating gRPC structures and methods for Python. Why we needed that? Because all our tasks are written in Python, that happened historically. Why standard generators don't generate this part, the gRPC services? I don't know, but nevertheless it is so. And we were forced to use the plugin that had been written in C++. Then it turned out that this plugin was moving forward too fast, and as a result, we were failing to generate code for old-fashioned Python. It just wouldn't translate in the new Python, in the old Python, I mean the new code. So we were forced to write it ourselves. And based on this it's based on this plugin that I will be leading today's conversation, how it's all done, why, and where. and gRPC mock. Unfortunately, we didn't have the time to release it into open source. For us, it's quite a long process related to legal processes and with security. So it's something that we wrote completely from scratch without rewriting anything. We wrote a service that if you have the required files in a certain place, would give you them. But if the files are missing, then it relays a request for implementation to the gRPC handler. It's being done so that you could do a quick job of test your gRPC client on the required data. So how it all happens. So we're writing the generator. So what do we have? We have a Proto3 format and Proto2, as strange as it may seem. It turned out that Proto2 is quite different from Proto3. They said Proto2 has certain things that Proto3 doesn't have. For instance, required, optional is present in both. Because some incredible number of libraries have been written in Proto2, including in Google, that regulates the development of this whole thing. So therefore, it's supported as a standard in all compilers. I mean, both of them, both Proto2 and Proto3. This QR code leads to the description of Proto3 format. You can read it up if you haven't before. If you want to get some practical value from what I'm telling, it's mandatory reading for you. Strange as it may seem, Proto3 documents may be very sophisticated because of the extensions that I will be talking about later. There's an option. There are options that are being described in quite a strange way, but nevertheless. What else do we have apart from the description of the Proto3 formats? We have format parsers. Actually, two: Protoc, a protocompiler written in C++, and Buff, that's written in Go. Some time ago, Buff was a wrapper around Protoc. Now it's not so. They've rewritten the entire functionality in Go. That is convenient if you want to take a look at what's happening with what you return from the generator, from the generator plugin. It's convenient to take a look at the source code. And C++ code is not, a nice thing to look at least the way it's implemented in Protoc. There's another tool that's gaining popularity, EasyCli, a command line interface. But it went along the way of early Buff. It's not a parser of the Proto3 format, but it's a wrapper against around Protoc. Those who use Protoc know that it's very difficult to call it correctly. There are no tools that allow you to put the library files the right way. So the wrapper around Protoc is written in Shell, in Make, or Go, or some other language. And it's mandatory for those people who use Proto3-based code generation in their professional activity broadly. So, now we move to the nuts and bolts. Perhaps a transition slide would be welcome, but I don't have it. So how it looks, I'll be using words to explain that. So there's a format parser that gets as an input a list of proto files that we intend to use to generate the code, and a list of plugins that are supposed to generate this code. The parser calls the plugin from under itself. Before doing that, it passes the proto files passed to it. verifying its correctness, and builds structures that it then serializes into the protobuf format, and that's quite interesting. On the one hand, we are used to use a serializer, deserializer for protobuf written in this language, but Protoc uses something different. But we remember that some predefined structure which has been serialized in protobuf, and so after calling a plugin for standard input, std_in, we pass this binary data resulting in the serialization into protobuf. Why am I dwelling on that in such detail? Because it came up as an unpleasant surprise to me some time ago, because for protobuf there were no schemas that one needs to figure out what to do to serialize them. So it was quite a difficult story. That was happening in 2018 when Buff was just a wrapper around Protoc. So returning the generated data is also the responsibility of our plugin in a serial protobuf structure to the standard output, std_out, and no other relations between the compiler protocol buff and the plugin are not supposed to happen, to exist. Now, once we are writing the generator, we need to select language. For me, there's no selection because I'm a Go evangelist. I write everything in Go, even those things that one might not need to write in Go. Maybe it would be better to write them in Bash, but nevertheless, that's what I do. Because Go is a compilable, portable, and simple, as in readable language. For this, we have modern gRPC tooling, for which part of the tooling only develops in Go. For instance, Common Expression Language is being developed just in Go, and for other languages, there are only bindings to these libraries. So, this is the way it is. So, we choose Go as the implementation language. So, of course, we're not going to write everything from scratch, so we'll take different libraries. The most important library to write the code generation from Proto plugin, it's a PhotoKit. The link is on the screen, the QR code is leading you there, but there's a bit of a problem there. It's quite outdated. So we needed to update it to the modern versions of protobuf libraries. So this link takes you to the updated version. Unfortunately, the author of the original ProtoKit doesn't even want to accept a pull request that has been sent to them. So most likely than not, we'll need to create our own fork of our ProtoKit to change the settings inside, the imports inside, so that the replace to Go mod should not be required. But so far, it is. Replacing Go mod is really a bad thing because if you don't have it, then substituting through Go install is not going to happen. So as a result, we're getting the code generation consisting of the main file and some libraries in the internal folder. At least this is the way it looks in my case. The link on the screen leads you to this project in the Python gRPC generator. And had we had more time, I would offer you opening it up and take a walk through the resources there. But unfortunately, we're not here in the masterclass, but it's just a conference presentation, so we'll have to move on. So this all of the main file that you saw in the previous slide. It consists of 15 lines of code, of which 7 are imports, and what we basically want to do. There's no pointer. We want to call the run plugin method from the ProtoKit, from the library that we've connected. We want to pass the instance of our generator to it, and so those std ins and std out, that will be used for the communication of the compiler with our plugin. So it's too dense. I'm sorry, too busy. But I mean, it's your own fault if you're sitting too far away from the screen. This is our generator. So the generator is a bit larger. So there are less than 100 code lines there. But nevertheless, what's happening there? So doing once, we pass the parameters, and I'll talk about that a little bit, some more details. We form the structures that will be passed to our generator, and we call, what do we call? We call the population of the templates.
This is the motivational part of my story. Everything that we need to do is that from the data that we have received to make some text which would be considered as a program, as a software. And it's best to take template text and from the template make the software text and convert it into the compilator is the best. So you can do that through std tree. I've tried this approach, but I realized that there is no grace in this approach. So all our generation is using template text. Why it's about motivation? Because look how simple it is. We write the text which we are going to use, the text which we would like to generate as a template. In template, there are different means of generation. There are some conditional operators. So if we are to familiarize ourselves with a template, we can describe what we need in the same manner as at PHP. PHP is, and there is also Python, Ninja. They're quite well, but our template is also good. And it can be used. The template on the screen generates the same text, which is generated by C++, Python gRPC generator. And Python gRPC generator looks like a series of sprints. When we have quite a long, by 400 lines, C file, we're using different ifs and loops. We make one long line which would lead to the resulting code. Why it's bad? Why it's worse than the template? Because in template, although it has all this syntaxes waste in double brackets, the text which we like to generate, we can learn this. I've used the well-known protofile. I've generated a Python file using C++ generator, and then I started to convert C++ generator text into a template. Some lines I had to remove, some structures had to be inserted, but it's simple. Colleagues, please raise your hands, those that think themselves genome. No one.
Тогда мой доклад немножечко не
Then my presentation is not for you.
надо было его немножко иначе строить, но я-то не знаю.
It should be different.
Важно, что
I didn't know. Okay,
в конце будет
doesn't matter.
мотивационная часть.
At the end, there will be a motivational part,
Почему так важно, что
and it's about why it's important, why it's simple to write your own
что вы должны
generator.
сделать, это
So
написать
what you need to do is to write your own template
отдельно, да, немного технического.
separately,
А,
some technical
Что
stuff
компайлера
from the compiler.
передавать параметры.
You may give parameters to the plugin,
Если бы эти параметры
and it would be logical if the
командной строке,
parameters would be sent like parameters in a command line.
параметрами командной строки,
We can cause the
нет.
process by parameters in the command line,
Для плагинов компилятора
but the parameters in the plugin
в качестве
from the
полей
profiler
той самой структуры, которая была
it comes as a field in a prototype structure
то есть вот в этом куске
formed by the
структуры
compilator.
прото-3 файла,
There are
кусочки лежат
proto3 files that have been parsed, and there are the
если честно,
files that we have specified in the config of the
разбор
compiler.
это делают
So to write the parameter
разбор параметров
breakdown
строки в структуру я
from the line into structure,
поэтому
I don't want to do that. I'm lazy for that.
вот так опять
So that's why I've done this.
я с помощью
It's
стандартной
small
пакета
on your
FLAC
screen,
сформировал
but using a LAC package, I formed a number of parameters that we expect, and using standard LAG package, I have parsed them.
в одной comma separated строке
They come in all
для начала
in one line, comma separated. So I am splitting this line by
но я просто решил, что я не
commas. It's not
слишком сложный
ideally correct
этот конкретный плагин.
approach, but I decided not to send too complex parameters to this plugin,
Компайлер склеил через
so that compilers have
разделить
glued this together after the comma can be separated using standard
вам тоже
parser.
придется что-то с этим сделать, потому что
So you would have to do something with this
другого способа получить параметры,
because there is no
потому что даже
other way. It's technoporno,
окружение компайлера
and even the
передать. Так,
temporal
теперь мы хотим
surroundings of compiler has to be purged, has to be cleansed
плагин,
before launching.
он там сам
So we are launching our plugin. It's
еще один кусочек технический
shown at the bottom,
недостойный.
technoporno. Somehow the compiler, when it calls the plugin, adds a preface,
ген минус.
proto minus and minus, and then there is the name
В случае это буф, он ведет.
shown in the config,
То есть бинарный
and a buff
будет искать
or buff behaves in the same way.
будет искать наш компайлер.
The binary
должен называться проток минус
has to be called proto minus gen minus Python minus gRPC, although it shows here short name. I cannot tell you why it's so. I have
вот он.
mixed my, there it is, wonderful.
Даются параметры.
How the parameters are sent for the plugins. Parameters are sent, this is in buff, in Protocol it's different.
Элементы, которые указаны в массиве,
The elements that are shown in the opt massive
они будут через
of this IML document,
соответствующие
they would be inserted
структуры, которые нам надо
into protobuf structure using the applicable field and using the commas.
Я не стал приводить
So buffgen or buffgen, I decided not to use command line for protoc because we're using buff. I haven't looked at protoc for some time. And buff generate is to call, to send the config file, and then everything happens. What happens?
вам показывать не буду. Потому что это
I'm not going to show you what happens exactly, because it is just a Python code, like a slide from a police academy that we need to watch for a couple of minutes.
можно было бы и закончить.
Here I could have ended.
Смотрите,
However,
вот этими мелкими
look on the screen in small letters.
одного из наших
There is a name of one of our proto files,
количество gRPC-шных
heading of our protofile files. gRPC
но, тем не менее, смотрите,
Collins
у нас
are
некоторое
outside
количество
because it's small font already,
указано.
and there are several options here.
Эти имеют
Options,
структуру. Вы тут
they have
мотивационная
particular
часть, вы
structure.
не ошибетесь.
So motivation part is you won't mistake if this option of gRPC gateway, proto
Если вы структуру эту
open
нарушите, вам об этом сразу
Apiva
напоминают.
2
Это важно.
Swagger, the compiler wants to keep this
Почему это важно, мы говорим.
structure,
Так вот,
and we discussed why it's important
они
with
где-то
your colleagues. These options, they are described somewhere, and there is a generator that understands them.
копия на Apiva 2
In this case, it's Open Apiva,
из
Open
OpenCC-шной.
API
Он
v2,
нужен для того, чтобы нормально
and that is required in order to talk with gRPC gateway, and gRPC gateway generates some number of code to talk to external users. There is a Swagger generator. So these options is an expansion for original Proto3 format. And this could be the most important thing from my presentation. You can take or you can write your own set of options.
QR-код ведет туда же, куда и ссылка.
The QR code is the same as the link. It's a description how options are formed for Proto3 file.
Все опции
All the options,
так или иначе наследуются от дескриптора.
they are inherited from a descriptor, which was given to us by Google.
Существует способ описывать кастом.
And there are ways to describe
Вот это то самое. Я не буду читать мануалы вслух.
custom options. I'm not going to read this.
Важно, что вот мы только что
So
написали генератор. Важно, что
we've written the generator.
обнаружили, что мы можем
We've identified that we can use
наш Proto3 формат
and add to Proto3 format options, which have to be checked not by our plugin, but compiler that would check correctness using Proto3 compiler. So you don't have to write the testing code to check it. So for me, this was a shock that this quite dumb system is not dumb. It's not dumb, but it's a framework to create languages, to describe protocols. And using option, we can do a lot. If we have a plugin being developed from the default value from this option, can make a generator of structures filled by default values that are as they are specified in Proto3. Because you know the structure, it's described in the message. You know what will be the values in the fields if you create them using this method. And most importantly, it's it's known by your colleagues, and it's the framework for communication with your partners. So this is going to work only if you want, if you don't only describe these options in the correct way for the proto-compiler to understand and parse it, but it's going to work if you will write the generator which will consider these options.
Выводы. Значит,
So the outcomes,
написать
first of all,
симулятор
to write
3 формата просто. Если у вас
our own generator from Proto 3
полагающая
format is easy. If you have an objective to make a generator, in Proto 3 files we describe config files for our services. Why do we do this? In order to show the validators, because in Proto 3, using those options for the plugin of validation, you can specify the sufficient number of values, which in validation for many situations you don't have to write it.
Min-max для числовых полей, и да, очень сложно.
There could be min-max for the figure fields, for the number fields, and this optional field cannot be present in a message if there is one more or the other is absent. So there are a lot of useful things there, important things. So if you have this objective, you can solve it, you can solve this task, even if you are a middle or upper junior, you can do this. And it's useful, so you need to formalize your communication with your colleagues and partners. I'm working for 2 years in a company, and I was surprised how important it is the task to explain to your colleagues what you are doing and what you are thinking, for your colleagues to understand your train of thought. Using your footprints can restore it like Plato's cave.
Однозначность высказывания. Мы можем с помощью Proto 3 вполне
Using Proto 3, we can be clear, crystal clear, and
никогда у нас документация, которую мы отдаем наружу, а наружу мы отдаем
the documentation which we give into Proto 3 or MD generated from this, it is always complies with what we do, is what we execute, and that is quite important. When we write a new code and the colleagues have downloaded this, and documentation they haven't downloaded, and trying to use our code in a different way, sending different number values that are not applicable. So it's quite a frequent problem. And there are limitations if all our talk to colleagues is about giving Proto 3 files, then it's quite a rigid structure, but it's quite convenient. And most important, it's fun. It's fun to create tools for the programmers. Perhaps there are software specialists that are writing those codes, but for me it's cool to write the tools for my colleagues, for programmers. It takes me one evening, and then colleagues can use it further. And for the juniors, it could be a journey from the Crudo writers into infrastructure team. In infrastructure team, the pay is worse, but the tasks are more interesting because they're always different. Okay, let me finish my technical motivational presentation. Thank you. Are there any questions?
Напоминаю, чтобы задавать вопросы, вам необходимо подойти к стойкам с микрофонами. И обязательно
Please come up front to ask a question, come to the microphone. Please use QR code, assess the presentations. It's important for the speakers and program committee. Between those that are going to fill the questionnaires, books will be given as a partially junior. I work in a data center in infrastructures, in high load, and I work at monitoring and mostly with engineering devices that work using industrial protocols. And as a DevOps,
Да.
some look at Proto 3 only as gRPC. Have you had experience, and do you perceive Proto 3 as a description of contracts between the installed devices on a low level?
Хороший вопрос.
It's a good question.
Смотрите, если
Look,
не лезть прям глубоко,
if we are not to go too deep, then Proto 3 is a serializer of protobuf, and protobuf serializer is not the best one. It's better than JSON for many applications, but Thrift, which is
незаслуженно потерял популярность.
somehow lost its popularity, it's much better as to the speed and compactness of data.
Если бы я о вот
So if I would
протоколах вел речь, то я бы
talking about
пытался избавиться
inputted protocols,
У нас тоже,
I would
система, да, но
remove protobuf.
они достаточно мощны, чтобы
We also have systems to
раз, два. Сами мы
include or install.
как источник
We are using Proto 3 as a source for generator of Swagger,
модули, которые
spikes, nuts, spikes.
И вот для того, чтобы
And
с собой связать, мы генерируем
in order to connect them, we generate some code. It's like a coverage of NATSIC streams. So for a couple of weeks, some of our seniors would
протокол. Собственно, когда-то давно, когда я работал на компанию, которая
because when I was working for a company which was making drones,
и начал для себя эту работу,
I started to do this work.
протокол
There is very highly effective protocol for the communication between devices in the network. However, the description for this protocol was quite rudimentary. The structures could be described, but the callings could not be described as in gRPC. So I started this work, but I came back from Dubai, back to Russia to work in Yadro company. So Proto 3 could be used in this way, but I don't know ready instruments.
Коллеги, есть ли еще вопросы или мое изложение было...
Colleagues, more questions? Or was my presentation fully understood by you? For your questions, we are going to present a book from Peter. Looks like there are no more questions. So you're the winner. You will get the book.
Ну что, Денис, спасибо большое за очень классное выступление. Давайте поаплодируем.
Денис, thank you for your cool presentation. Let's applaud to Daniel.
Итак, сейчас я прошу вывести слайд с расписанием на...
Now the slide with our program for Saturday. On Saturday, we're going to have workshops on AppSec, on DevSecOps,
доклад от нашего спикера из
and a presentation from our speaker from Iran. So please follow QR code, look what you need in addition to laptop, study this, and please join us. Now I'd like to invite on the podium our next speaker, Anton Chernousov, advocate developer from Yandex.Cloud. Thank you.
Уважаемые коллеги, друзья,
dear colleagues,
очень рад всех здесь видеть.
Friends, I'm very happy to see you all, and I'd like to welcome our online audience.
Поговорить про две, с одной стороны, не связанных вещи, но которые в моей голове сложились в одну очень простую.
Two things which were not connected I'd like to share with you this concept. I've asked guys, and I think that it's interesting for you. There will be no hardcore, there will be no super difficult things, so please relax. Everything is going to be quite light.
Мы с вами живем в современных инфраструктурах.
So we live in modern infrastructures. They are quite complex. And as a
Работающий в Яндекс.Клауд, сказать,
advocate developer working in Yandex.Cloud, for me it's important to remember,
важно в каком,
when you are working in a cloud, you are always working with a
все компоненты, которые вы используете,
constructor.
чем
Everything that you are using, all these components are like bricks. And the better they suit each other,
любой
match each other, the easier it is to work. And it's important that every operator thinks on how to connect
свой
so that you may build your own spacecraft, which is going to grow, and you connect bricks to bricks, and then you make a huge spacecraft. So you are constructing your systems, and the way they work, it depends on you.
веду подкаст. И
I have a podcast,
хобби. Кстати, если вы слушаете
The
подкаст
Art of Programming,
или иногда делаю опросы, один из таких,
and I'm making some surveys among
когда
my
пьют кофе. И вот как
listeners when they relax, when they drive, when they
просто
drink coffee. I had a question in my mind:
event-driven архитектура.
event-driven architecture.
Зачем?
What is it?
Я, недолго думая, спрашиваю,
And I asked my colleagues.
прекрасную книжку. Я такой думаю, блин,
They recommended me a beautiful book, and I said, "Who is reading books now?"
кайф. Значит, я такой думаю, книга это долго. Может быть,
And book is longer, so I thought that maybe there is something simpler.
что можно посмотреть, почитать. Знаете,
And I looked at different sources that are more interactive.
ссылочки посмотреть.
I've collected them. You can look using this link,
Сократить количество времени на изучение,
and you may
по крайней мере, поверхностно,
reduce the time to study
такой обзор.
10 times.
Но все равно много. Я думаю, ну,
But it's still too much because I'm drinking coffee. I want to make it quick.
такого common sense
So I decided to
как разума спрошу.
ask the common sense
Является, ну, какие-то
GPT.
event-driven архитектуры мне дают.
So what is event-driven architecture? And they give a definition which is adequate, which is easy to check. I've checked it in different systems.
Подход,
So briefly, it's an approach
в котором компоненты
in which components,
взаимодействуют с друг другом через
parts of the system, interact through event exchange.
вроде бы ничего.
It's quite simple,
События
nothing difficult. What kind of events?
это какие-то
Events
изменения, которые
are
снаружи или внутри системы генерируются, и
important changes,
некоторого пакета данных, ну,
and there is some
некоторый жизненный цикл.
package of data which has its life cycle.
Попадает в систему, хранится.
And it gets into the system, it's been updated,
То есть какие-то функции,
and
которые события
then
работают. Я такой думаю,
utilized.
event handlers,
And there are some event handlers.
что-то знакомое.
I thought that I've heard about this
Когда пришел в Яндекс.Клауд, я стал заниматься
because when I came to Yandex.Cloud, I started to
важной для меня темой сервера.
do a very important thing for me, which is serverless.
В принципе,
And in serverless, everything is about events.
я такой думаю,
It's a
я же этим занимаюсь.
event
Прям
system, and I thought that I am doing exactly this.
если очень
So
общо на это все посмотреть, практически любое
and
приложение, это приложение построено
any serverless application is built on event-driven architecture. You may not know about this, but it's so.
2 секунды у вас украду времени, поднимите руки.
And just 2 seconds, who is using serverless right now, or seen some examples? A couple of hands, some few hands I see.
Смотрите, очень важная история сама по себе.
It's a very important story.
Когда с этим
Just 2 minutes for those that haven't seen serverless.
дело в том, что сама первая успешная реализация
The first
случилась в
commercial
АВС запускает свой первый сервис, который называется
happened in
суть его заключается в
2014.
следующем. Мы берем кусочек
It's AWS Lambda
да?
by Amazon.
Написали небольшой скрипт,
You can write it in Python, a small script, and then you throw it into the cloud to work at certain address. When there is a user query,
на машине, и
it's launched on a small virtual machine, and it's sent to this
и в тот момент времени все-таки,
function.
как же круто, все резко побежали.
And at that time, I thought that how it's cool. Everybody wanted to have this.
Подключили, сделали свой
And there is a story. We've done our own service, but a bit later.
сервис вот этого первого базового
Function as a service, the first basic service within the serverless applications, there are three principles. It's abstraction, because we do not own servers. We own a part of code which we operate, which we create and change and put into the
потому что платформа
cloud. Automatic scaling, because the platform decides if there are too many queries,
автоматически поднимается в рамках нашей квоты
too many demands,
инсталляции вот нашего вот этого
then
маленького кода, который мы положили.
it's number of installations of our little code which we have inserted into the platform. And when they are processed, they are switched off, and then some savings that are there. And this was to prevent
Для этого сделано.
chaotic components.
Надо сказать, что, ну,
And I should say that
сейчас. Очевидно,
back in 2014, now it's 2025, there are a lot of changes, and there are some archaeological artifacts.
хочется копнуть эту тему прям глубоко, то есть вот в прошлом году вышла прекрасная книжка.
So last year, an excellent book was published, if you want to delve deeper into that.
Сделана во всех
So if you remove the word AWS, here you'll see a description of how it's done everywhere.
Если хочется коротко, потому что мы
So if you want to have it brief,
вроде как нет.
because it's like it appears that there are a few people who read books and others don't. So you can use this link, and Maximilian and Emily will take 45 minutes to explain how we write the code, here how it starts, how we escalate, what the challenges we encounter. Actually, you can take 40 to 45 minutes to see how it's explained. And what they're talking about is like a base. It works the same way for everyone. The only caveat is that they are presenting it kind of an advertisement.
Вот, там все
Once you start getting deeper into that,
практически, они как вот слоями.
so you'll see that there are certain myths that have accumulated for several decades.
В статьях, которые
And I mean, I prepared a special presentation to dispel those myths. What's indeed a problem, what is not a problem.
быстренько
And you can watch this, and it will take you like 40 minutes to get updated to the state of the art.
о серверах.
Why
Зачем?
am I talking about serverless?
Много людей прямо сейчас
And what for?
в инфраструктуре, но это
There are not so many people who already use that in their infrastructure, but it's important. If we take a look at some cloud layers, so for instance, if you have a traditional infrastructure, so we look at everything from the ground to top.
где-то
So
столбик сервера
there's EAS and PaaS,
функции.
and we indeed write only functions.
Так важный момент заключается в том,
So the important point here,
что параллельно. И каждым годом подсматривают друг
the important point is that all these layers exist in parallel.
перетаскивают к себе. Таким образом, очень интересное явление, я заметил,
And there's quite a curious thing happening over the past 2 years, at least. A lot of large companies build their own platforms,
сервисы, которые внутрь себя втаскивают.
different PaaS
В
services.
том числе концепции serverless влияет на то, как они
And this serverless concept affects how they do PaaS.
на это внимание.
So if it's possible for you, please take a note how it's done, because in your large company it may appear as well, maybe a little bit later. Why am I so confident talking about that? Because if you take a look last year and the year before last in AWS, and AWS plays the role of a flagship for us, showing what changes are going to happen worldwide in 5 to 7 years, depending on how technologies are going to develop. Then in roughly 1 in every 2 presentations, there's this part. So how it happened, how it was done before, and this is the serverless bit that we inserted. So this is how it's been happening in all major companies. And I must say that large infrastructure start living on parallel.
который рядышком по вот этим
So,
живет. При этом вы разворачиваетесь тех,
as I said, you
у вас какая-то
deploy from the same repositories and you get such a rich infrastructure. It's clear that to serve a large
это не хочется делать вообще.
large-scale infrastructure manually, it's something you don't want to do at all. And as a whole, as a developer community, we've long
Средства автоматизации и
arrived at the need to use some automation tools. And of course,
инфраструктура.
IEC, infrastructure as code tools come to help us. This is the second part. These tools support us as developers, helping us deploy our infrastructure. Let's go through all of the tools that we use. They appeared in a certain sequence, but if we just run through them and leave your scripts outside, it's obvious that a long time ago it was Bash flying over the waters of the Nile. It stays in your heart, but you want to have some sweet things
Так, вот.
to be felt. And of course, we have,
Императивный DSL.
for
Очень
instance, imperative DSL.
инфраструктуры
These tools appeared very fast. As soon as infrastructures became very large and deployed in the cloud. So these things appeared, emerged, we started loving them, but actually one would think that they got obsolete, but they keep being developed and they keep affecting us. And if you want to stay on the wave and attract some new practices to your current work, I recommend that you look at what's happening there. And here are references to 3 great presentations. One of them impressed me a lot, from Pavel Vorobyov.
не пользуетесь.
And the question is, even if you don't use them, but these approaches are going to affect you because, as I said about the cloud level, they live in parallel. All tools, all layers, all everything, they live in parallel, affecting each other. So then declarative DSL appeared, the most well-known platform. In a certain sense, we describe the target state, and the framework brings our infrastructure to this target state. Of course, FAPEC is not mentioned here, but nevertheless, they all work about the same. Then other more exciting toolkits appear for serverless, for instance, serverless DSL. Providers themselves started developing cloud development kits. It's clear that it's a very convenient thing for integration. These are specialized libraries, in a certain sense, that allow us. It's like a pattern builder, largely speaking. So we have code, we live with it, and it offers us an opportunity to build our infrastructure code next to it. It's very convenient. It allows us building our infrastructure in a unified pipeline, in a certain sense. And then serverless CDKs appeared. But conceptually, none of these was solving our main DevOps problem because, largely speaking, at the end of the day, we wanted to get some closed circuit within which we would write code, not dealing with the infrastructure part. Developers don't like dealing with the infrastructure. They say, so I've written the code, it's ready, it works, so this is the bullet that I shot, and then it should somehow deploy automatically. And with DevOps, everybody is starting saying poo-poo-poo, and this poo-poo-poo
строится, потому что
is now being built around Terraform as much as it is possible, because it's quite useful tool set.
травма.
Unfortunately, this toolkit has some birth diseases. And when I was drinking coffee, I thought that these birth diseases
Но нет.
are compensated in the infrastructure. Not all of them, but some of them. And I thought one could delve deeper. And I found two things that
Входят
can
в
be
нашу разработку.
that can be easily integrated into your development as soon as you start using event-driven architecture approaches.
Давайте вот,
Not all of them, but some aspects. So let's consider two problems
по крайней мере, вы
with which you should start. At least you'll be able to see the solution in a very simple way.
чем больше у вас команд одновременно работает над чем
So the more your team is going to work on the architecture, the more difficult it's going to be with everything else, because we're keeping a certain state. Infrastructure is a file in a certain sense.
проблемы с управлением.
So this may cause some problems with management. Should be done centralized. It has to be protected in some way. But again, we're running into the problem of syncing, aligning this whole story, because we have different teams. One needs to start, another one to wait. Some common pipeline needs to be maintained. So then the infrastructure needs to be analyzed, and everything should be in the same listing. But the more components there are there, especially if you have a well-developed infrastructure with lots of settings, you start dying, drowning in all these things. And as a developer, you don't want to do that at all. It's clear that we start fighting that with the state. We keep the intermediate state in S3 and the locked one in the database. So
Вроде бы что-то немножечко
it's a temporary solution, but it works. Why not? So it looks like you have it stabilized in some way. But how does the event-driven architecture impact all this? What I liked very much when I started going through this was the statement of Adam Bellmer. He, as a staff technologist at Confluent, made a very interesting hypothesis that all more or less large architectures deployed gradually, step by step, not even understanding that, to migrate to become an event-driven architecture just on the basis of the scope of changes accumulated in the system. You start using those approaches, not even understanding that you do. And a large part of this work is that when you're starting from in the mode microservice architecture, the systems exchange information, issuing and consuming events. So the whole looks right. We have service A, service B, there's some queue between them. I threw some data into that queue, then the system has read something from this queue. Does it make the system an event-based? Well, of course not. But if we replace a regular queue by Apache Kafka, because there are pipelines there, we can subscribe and unsubscribe, we get a fully pledged producer and consumer, then we seem to be getting quite close. Simply, we've just replaced some unknown queue by Apache Kafka, and nevertheless we get that. And a more noticeable change is in that we, largely speaking, in our infrastructure, identify conditionally independent components. We split our architecture in terms of sense, in terms of meaning. We can keep managing it through Terraform, but what do we get here? Conditionally independent components, because why? We have clear delineations in the login. So within the structure, you say, so here before this event, it's one thing, and after that, it's the responsibility of the platform team, for instance. And we get into separate deployment of service component. So it's just that we take this huge Terraform that has been growing because independent teams have been working on it, not impacting each other, so that we're split through the events. So it appears that we have been able to unlock this tangle. There are a few technical moments here that we can discuss separately, but on the whole, with each team keeping the state in the database and the log state in the database, we get some order. From this, a certain order emerges. The system seems to have become more complicated, more complex. And one starts thinking, so it's not just a simple queue, the quorum, and updating is becoming a more difficult process. And on the whole, when you start building an event-based system, of course it becomes more complicated. And we run into problems related to the updating. We can identify three basic problems here. One about adding new services when a new team has built a new service. It's about updating of old services that are already running under load, that consume some data from this queue, and scaling of the system based on the growth of the load. So the infrastructure doesn't seem to have changed. It's just the size of the load has grown, and it may be just a regular seasonal load. But that impacts our systems and our infrastructure components in terms of deployment, I mean Terraform. So some problems with updating. It's manual intervention. If this is not good, generally speaking. If from the point of view of infrastructure as a code, we should take in everything into IIC and run it manually. This does not seem to be quite nice from the practical view. But what if somebody has done something undocumented? So it becomes difficult to automate. Again, there's a problem with change reversal. If we do that, Terraform as such and most IIC components don't support automatic rollback. You need to do it yourself. And also, you need some additional effort to invent these rollback strategies. And again, if we are limited in diagnostic tools, errors, so we don't quite understand how what the current infrastructure is about. So what does EDA give us for updates? Then we get into the very interesting part. One of the basic properties of any EDA architecture
слабая связность компонентов.
to a certain extent is about loose connection between components. Why? Because they interact via events. Unless I have read the event, they're waiting for us. It's a kind of a contract. In terms of a contract, it's about a commitment from the other side regarding how long they will be waiting for me. But nevertheless, the components, because the scope of the components is limited, they are independent in a certain sense. So, of course, in a certain sense. And colleagues,
Я вижу, что,
I see that
если посчитать, наверное, здесь тысячонка наберется на всех.
you sum all of you together, you have 1,000 years of experience at least. Who has used blue-green deployment?
Вот тут еще.
I see people here. Yeah, super, cool. It's a classic pattern, isn't it?
Сам по себе паттерн.
And generally, this pattern as such has been known for a long time. The pattern of continuous integration and continuous delivery, CI/CD, which allows us deploying components smoothly and safely, migrating from the old version to the new one. Actually, this whole story considerably simplifies once we start using EDAs. And doing this, we also solve three problems of updating: traffic, data, and deploy. How do we do that? We have a consumer, of events.
События, то есть тот самый
We have the events, meaning the incoming traffic. It's being accumulated somewhere in the intermediate states,
более того, мы можем использовать
and the system accumulates it before we can update it. More than that, we can use other ways we can take these events and start servicing them on parallel in order to make sure that everything keeps working, to provide for the gradual change of loading,
все параллельно.
and everything is happening in parallel.
В том, что
You need to read all the events. One of the properties of the architecture is that we don't destroy the event after processing. We keep it following some policy. Quite often, when you build a system, you archive these events, you load them somewhere so that if needed, you can replay the state of the position of the system, step by step, move by move. What happened? What changes were introduced? How this packet was processed? You can archive, you can save it for some checks. What that if we work on an event-based system, we can test our system for new workloads, because we have a pattern of the workload stored. It's clear that there may be different and a lot of different strategies. I'm not going to dwell on that. One of them from me about safe adaptation migration, and another from my colleague from T-Bank about zero data deployment and database. So my colleague has done a good job preparing that. In any event, several things are important that I'd like to mention. We automatically come
event-based системы, мы начинаем систему развивать.
to the use of event-based approach when we start developing the system, making its work more complex, and try to split into two parts.
Команд много.
Because there are lots of teams, there are lots of components, and you don't want to step on each other's feet while working. And these small changes related to the change of limited context that we work with allow you changing the entire architecture. When you start thinking about restricted context, then you recall stories about domain-driven design. It's an approach to software development, software design that comes in quite handy. There are three very good books. The freshest one comes from Vlad Kononov, and there are a couple from Adol Belma. The second one was released just last year. It's a great book. One is about microservices, the other one is about data meshes. Technically, it's a very simple story. All the bonuses from the interaction between the core and infrastructure codes are obtained by applying two things. Firstly, restricting the context of the components, and second, from the fact that we start managing the infrastructure through independent components, while all the well-known methods of infrastructure updating are applied. But the split allows us reducing the load, reducing the complexity, and improve repeatability. The problem is that there's a problem that we don't have solved here. The problem is related to the support of APIs from different it's like one of those bad things I would also like to add to our discussion. I wouldn't like to bypass this point. This problem has not yet been solved and may not be solved in the near future. Please raise your hands who use Terraform quite well, who can write modules, Terraform module. So I see some hands here, there. Great, super guys, thank you very much. It's really cool.
Вот возьмем какой-нибудь
So, take some component.
Приложение
For instance, I have taken some serverless app. I have some external supplies or events. Under the hood, I have some system that sends events to me.
Тем не менее, если
Of course, it's not an event-based system, but nevertheless,
то
if I go really deep, I'll see that it's building blocks. Say those same building blocks that we're talking about. They're simple. They're limited to the structure of my app, and the smallest of those building blocks is usually a function. A piece of script, a script in Go, in Java, whatever, is just supported by my platform, can be run as a separate element. In terms of event-based architecture, it's just a regular classic component that can be a consumer or producer that can supply some data to some queue or to some message processing platform. So how will I deploy it? I'll take classic Terraform and write down a listing, although how will I write it down? Here's a second listing, I'll need cover thing, third listing, fourth listing, and then I get tired. Look, it's just about 10 lines of code, so why should I put that? And colleagues are writing Terraform's module will tell me, Anton, look at me. Just write a Terraform module, so it should be quickly done, and everything should be processed immediately. And what if I want to deploy this function, this component, this element of an event-based system in more than one provider? What if I have several present points, and you tell me, oh yes, you can write it for here, for there, and more than that, you'll probably have to write it inside the code, here, and here, and you'll write it in different ways. So everything will come apart, and I'll say, but how can we do it somewhat differently? I wouldn't just like doing that. And how would you like to do that? I would like to do it in such a way so that I should just write it somehow once, and then it should somehow, evolve. And okay, it may deploy different ways in different places, but without me, so that it should go there.
чисто технически
Yeah, but purely technically,
подход
this approach,
развивается, и это
it looks like it's being developed, and its infrastructure from code, IFC. 3 principles have been formulated. First, low ops. So we would like to have it as little as we can. So it should be
честно, да?
comfortable for the developer, and so that it should be vendor-free.
Было со мной.
So that I wouldn't have to worry about that.
И с одной стороны,
On the one hand,
к этому все движемся.
we're all moving there.
Свои API,
We're opening our APIs.
рассматривать у друг
We're trying
сделал, чтобы делать более-менее
to
одинаково.
look from behind a shoulder from everyone, trying to do everything in the same way. And different developers say that why don't we build some framework that would wrap around your code so that you could deploy it in a standard way. So a classic example comes here, Nitrec.io. So you can take your app, they be wrapped, and then with a plugin in the infrastructure code will be written, and different clouds will be supported. And you can write it yourselves, I mean, both the plugin and the adapter. In this sense, it turns out that I'm writing code, it gets automatically wrapped, and then I can deploy it in different platforms. But so far, it has been quite, rough and raw. So this wonderful dream, so that we should split everything into components. The components so simple that we could describe them fast in code, so that they could deploy as building blocks on any platform. We're not yet there.
в своих платформах.
You, as developers, live not in the world of dreams, but in your specific platforms. It may well be that your company has its own platforms. And what do developers do? Will they be looking at what's happening in parallel and try to build it into your platforms? And so sooner or later, it will come to you. Some parts of serverless systems, some specificities of deployment. In any way, you'll be building your great spaceships.
Конечно,
And, of course,
структура растет,
if your infrastructure is to grow, if the load is growing, if you operate with events,
мигрировать на этом
then it's quite obvious that you'll be migrating on this spaceship towards the core,
подходов.
the approaching, and what
У вас
next?
есть время
And next, if you have the time
оставаться
and desire to
на волне,
always stay
смотреть какие-то из материалов.
on the wave, I recommend to look at some of the materials that I collected under this link,
Влади упомянут.
paying pay special attention to the thing that I haven't mentioned in my presentation.
Закачиваем инфраструктуру в
What it's all about is that when we deploy the infrastructure in some cloud, we find ourselves in a situation where we start paying for it.
это касаться не хотим.
Well, bloody hell, we as engineers don't want to touch this subject.
Делает
And once DevOps does that instead of us, or on our behalf,
по цеху.
I mean, some colleagues of us,
Этой истории не касаемся. А она для
we don't touch this thing. And it's quite important for us as engineers.
как дисциплина
The point is that FinOps as a discipline helps you assessing
еще один параметр очень важный.
one other important property of your solutions. How expensive is your infrastructure and how expensive are those components that you're developing?
Очень важную и очень простую.
EDA helps doing quite an important things because the contexts are limited
Через IAC вы можете
and you deploy components through it. You can do one of the simplest practices in FinOps, labeling of resources. You can, from the outset, mention
собирать аналитику.
which projects they belong to, for which issue they are, in order to collect analytics. You, as engineers, can take care of some aspects from the get-go. So if you familiarize yourself with my presentation under this link, you can get some ideas to this effect. With this, I would like to thank you for your attention. Thank you for raising your hands, and thank you for being part of this.
Обязательно приходите по QR-коду.
Please use this QR code, assess. Anton will take a great pleasure. I will be very happy. The program committee will be very happy because among all those who will have voted, a book will be drawn about Leslie Babbage. Please leave your contact details and we'll send everything to the winner. Okay, if you want to ask questions, please come up to the microphones. Come up to the microphones and shoot, ask your questions. And we are going to give a book from the Peter Publishing House for the best question. Okay? Okay. Okay.
Это означает, что все было...
The light is glaring in my face. So please raise your hands for whom everything was 100% clear. Okay, not bad. All right. Please raise your hands who still have some questions.
Так, а почему вы не у микрофонов?
And why are you not at the microphone? Okay, I see you there. Hi. I wanted to ask a question about this subject. So, if you're mentioning some specific words, Terraform, Kafka, is EDA an approach? So maybe we should say Kubernetes, and then we will remove vendor lock it'll be about a transition between clouds. Why don't you add this word? Okay, thank you. What's your name? Dmitry. Dmitry. Thank you very much for your question.
Важный момент.
The important thing here,
Kubernetes надо рассматривать.
Kubernetes,
С одной стороны, это все-таки
on the one hand,
я люблю подходить.
I'd like approaching these components
Kubernetes это платформа.
as an environment. Kubernetes actually is a platform within which you deploy your applications. And if you also believe it to be a platform, one of the platforms,
Использовать свою собственную
so you can use your own platform,
в том числе. Вы можете
okay?
свои приложения поверх виртуальных
You can build your apps on top of VMs. You can build them on top of
деплоймента.
codes within Kubernetes, but you will still face deployment issues. Again, it will be built around Kubernetes, automation tools. If you automate this whole thing using code, more likely than not, it'll be Terraform.
Обратно
I tried to fit Kubernetes in there, but I understood that I rolled back to the state. So you can take this as a standard. So you've taken Terraform as a standard. Why don't you accept Kubernetes as a standard? Because in that case, that would fit very well.
повторю, как бы
So for those who are online, I'll repeat part of your question.
возьмем и
If we take
стандартных элементов
as one of the standard elements, if we use Kubernetes as one of the standard elements that will be carrying to every platform, one would think that we'll have the same platform everywhere. Actually,
облачного управления.
the maximum value of any cloud provider, where you go. So forget about anything. Forget that I work with Yandex Cloud. You'll get maximum value at the moment when you start using
Сервис
the services adapted to this particular cloud, because that will reduce the load on your engineers, even if you start using some managed databases or queues deployed there, some other components. The more components you start using in a specific cloud, the lower the load will be on your development teams. As a company, you'll be able to move faster in terms of development and value deployment. So limiting it to just Kubernetes, you will make sure that your load becomes higher.
вы на себя
It's a very strong restriction that you impose on yourself. You accept all the risks as your responsibility. And it's an important point. So if you're living in a cloud, then you should take care of risk being shifted somewhere else. You can, of course, discuss what kind of risk can be delegated, but that's an important point. If you're prepared to take it up, why not then?
Так, единственное, вас плохо слышно.
Okay, the only thing I can't hear you very well,
Хорошо.
and I think that applies to everyone.
После доклада
I suggest that we continue discussing this one-on-one after the presentation. So next question.
Доклад очень интересно, очень живо.
Thank you very much for your presentation. Very exciting,
Послушать ваше мнение. Вот
close to life. I would like to hear your opinion.
серверлес,
How you,
а какой
as a visionary of serverless and low ops,
инженеров, они, может,
what do you think? What will be the place of low ops engineers in the future? Maybe they'll transform. Maybe maybe it'll turn into a different specialization. Maybe they'll get extinct. What's her name? Victoria. Victoria. I think there are three trends that we're seeing right now. Trend number one,
автоматизация
it's about the automation of routine operations, put it this way. The entire toolkit that we see now is basically focused on automating routine operations. Unfortunately, this glue level between toolkits remains on the shoulders of the people. On the one hand, you have to set up automation, and on the other hand, you still do some, manual clicks. So because seamless integration is not happening. So this is the place of DevOps engineers, people with deep expertise in DevOps practices. That's thing number one. Second is what I've been saying for the past 2 years. It's about an emergence of different sorts of AI agents that help DevOps engineers in their work. They help assist rather than replace them. It's an important distinction. It says your performance will grow. You'll be servicing more teams, more products within your ecosystem. That's the second part. So using these tools, you'll see your performance grow. Of course, there are subtle things there. You can discuss certain things, but nevertheless, this is the second thing. And the third thing that covers or completes this whole picture is related to the fact that over the past few years, we've been observing a move toward multi-platformity. So the approach where you don't live within the same cloud of one provider, but you have this infrastructure for this, and then you have another infrastructure for that, and the place of a DevOps engineer, and for these specialists, is very important. It's in the expertise of deployment in different environments, because the developer who's focused on implementing business logic, their expertise, it's all there. They can't you bridge this gap between different platforms. It will always exist, and you, with your expertise about that, you'll be able to embed this code into this environment, add the glue, so that a lot of different teams could, interact and scale. And that will be your responsibility area, and then it'll be growing through the roof. Thank you. Thank you for your question. Okay, friends. Are we going to have more questions? No. There are questions. Okay, please come up to the microphone. And while we're waiting, let me remind you that this Saturday, in this very room, we'll run a programming Olympiad. Please come here, get registered. There'll be exciting tasks, problems presented. Thank you for your presentation. And now that we're at a security conference, my question will be like this. How the EDA approach matches such things as either potentiality, anti-brittleness, when services are created and they don't change, and all the changes turn to complete redeployment of these services. Thank you very much for your question. I didn't mention one very important characteristic of serverless. It's the fact that you redeploy it completely. A new VM is created, a piece of code is put there, and it starts. And once a user request is sent, it is shut down. All the memory is flushed, everything that was there, everything is deleted. And the next approach goes to the next VM. So it appears this way. If we have a system that supplies events, then actually the event always arrive at state zero. So this is a perfect state that we are moving towards. So this is the way for us to solve this question of getting rid of some remainder data. It's not always done this way. It's just a quality of those serverless systems. And it's one illustration how we start borrowing approaches from each other. So all this story with the serverless, with VMs, comes from there. You can immediately do it on serverless components of the same functions. There are a number of other components that work following the same principles. And then we get these characteristics from the outset. Otherwise, we have to bridge this gap manually in terms of secure development. I hope I've answered your question. Yes, thank you very much.
Есть ли у нас еще какие-нибудь вопросы?
Okay. Do we have any more questions? If you just try to ask a question, the microphone. Anton, you're not running away. You'll be able to catch Anton at the fringes and talk to them. So you now have this problem of choosing one question out of those great questions that you've been asked. Who to award the book? Victoria was here. Great. So, Victoria, great question. Okay, thank you very much for your question, for attention. Victoria, please come to the stage and we'll hand you the books. Thank you for your time. Thank you for your attention. Anton, thank you. That was just awesome. Full show. Okay, with this, I would like to say goodbye to you. As the host, we have a small break, and then we are going to continue at 2 p.m. I'll wait for you here. I'm waiting for you right here. Don't forget about the programming Olympic.
Меня зовут Мария Церетели, и я один из руководителей Т-банка. И сегодня...
My name is Maria Ceratelli. I'm one of the heads of the T-Bank. All right, we haven't yet connected, so let's say hello once again. My name is Maria Ceratelli. I will be hosting the rest of the day in this room. I'm one of the heads of T-Banks, and I do a lot of things related to what Positive Technology is doing. And today we are going to hear a story how developers solve the problems with source code given by Georgi. I can't see them. So let's give a louder round of applause to welcome Georgi so that he would make it to the stage. Hi, everyone. Microphone. Check, check. So it's been a year, and we're seeing each other once again at the PhD Positive Hack Days Fest. So I'm happy to see you all. So the title of my presentation actually has a lot of meanings. The small composition that we heard at the beginning, and it's really original, was performed by Joe Perry in 1994. I'm not Joe Perry, I'm just Georgi Alexandri, lead development of the statistical analysis of software source code from Positive Technologies. My today's presentation is the third one in a series of presentations related to the exponential growth of data in symbol analysis. So what are we going to talk about today? You know, after the first presentation of this series, we were talking about a special case where the growth of data is much lower than exponential. In the second presentation of the series, we are talking about how to use different heuristic approach in order to cut corners, to use all sorts of approximations to reduce the size of memory and to mitigate this exponential. After these two presentations, quite an interesting feedback came. People said that these are quite exciting topics, but on the other hand, the formulae used in the presentations make the perception of the material more difficult. And on the other hand, they play the role of a certain step in these developments. So let me bring these things together. Let's first talk about general things related to symbol analysis, and then discuss that exponential problem using the formulae that we have already got used to. So let me remind you what symbol analysis is all about. But for this, you need to recall the idea of abstract interpretation. It's some transformation of the source code into some other presentations to research the properties of this code. All this said, the interpretation of code is not happening. Symbol analysis, an explicit interpretation of code is not happening. Symbol analysis is based on three tenets. That symbolic execution. The second one is that all the data, the parameters of inputs, calls to this outside systems are mentioned by symbol analysis as unknown data, the symbols that can take any admissible values unless there are some constraint imposed on them. And the third tenet is that symbol analysis operates with all the possible branching waves in the process of execution of the source code, because it meets the unknown symbols. And if someone wants, then using these links, you can understand the definition in a deeper and a more formal way. This said, symbol analysis is not a new way. People started talking about it at the end of the 80s when the first works appeared saying that symbolic analysis can be used to generate test scenarios in application development. Then at the end of the millennium, some work in the neighboring areas started appearing where researchers started discussing if there are other mechanisms that can be used in symbolic analysis. The renaissance of the symbolic analysis happened in the middle of the first decades of the 21st century, when all sorts of implementations appeared. Some of them are shown in the slide that I have selected following my own internal feeling. And now we can say that we're at a stage when hybrid approaches in the implementation of symbolic analysis appeared. So from all the symbol attempts are made to take things from other areas into symbolic analysis in order to get problems solved. A certain mathematical data model is used in symbolic analysis, which is called the symbolic virtual machine. It's IMC. Now, any mention of DMC, Devil May Cry, is absolutely circumstantial and was never thought of by the scientists who developed this. Okay, it's a joke. So the first element here is the current instruction in the source code being analyzed. The second letter is about the memory of the virtual machine with registers, variables, memory areas, and so on. And the third component is the current condition that you get, or feasibility condition that you get with symbolic analysis. Quite often it contains the unknown symbols. I'm sorry, the clipper doesn't work. And if you got interested in how exactly the translation of instructions is happening in symbolic analysis, what kind of data is used in symbolic analysis, and also what's happening under the hood, then you have an excellent opportunity in exactly a month from now to visit the great city of St. Petersburg and listen to the presentation about that. And you get more information about this following this QR code. Okay, that's the end of my PR speech. All right, in our symbolic VM, we have this condition. And researchers, when they started to design all these series in the 1980s, already asked the question. So we have a VM, just a regular VM, and it has a specific feasibility condition. It has some value. But what to do with a symbolic virtual machine where this condition contains some unknown symbols? And in a general case, it's not clear how to interpret them compared to a usual VM. Just like it always happens in mathematics and computer science, we got help from the neighboring areas, exactly from the Boolean satisfiability problem and the satisfiability modular theory. There are local variables, brackets, and all sorts of logical operations there. As an example, you can use a statement of the form A or B. And in the satisfiability analysis, we're talking in terms of a logical formula that can be applied in a certain theory. It could be a theory of substantial numbers or regular numbers or others. For instance, example conditions A is more than 5 or less than 100. In this case, as a theory, we have a linear theory on integers. In this sense, SMT is even older than symbolic analysis. And as of today, we can say that there's implicit organization and the official standard of the same time, SMT-lib, satisfiability modular theories library, that says how you can formulate these things so that SMT solvers could get some solution. So to understand if the solution is feasible or it is false from the outset. So I'm showing some tools here that allow doing that. Let's take a look at a simple example of an SMT request, understand what's happening there. In the first operations, certain SMT options are being set. Then we set the theory based on which we're working. In this case, we say that our theory is a linear logic over integers. Then we declare variables, and then we get the main block setting the constraints, the feasibility of which or impossibility of which, inachievability of which we want to check. In this case, we have two linear equations of this form, x times 2y equals 20, or x times y times 2. So we check solvability, and as you see here, it is. And in the last command, we get the specific value. In this example, we see that we need to take x equal to 8 and y equal to 6 to get the solution. This is how SMT looks currently. We got a bit digressed. Let's come back to symbolic analysis and take a look at this on this example, what conceptually it is. We have a small function that accepts 3 parameters. In the body of functions, we have a declaration of 3 local variables, x, y, and z. And in the management branches, we add some values depending on the input parameters. And at the end, we return the concatenation of the 3 variables. At the moment of concatenation, there are 2 admissible values for each variable, and the concatenation in sum generates 8 admissible values, because for every local variable we can take one of 2 admissible values and combine it with the rest of the admissible values. And had we had n variables rather than 3, and if every variable had k different values, we would have got, omitting some parameters that we have considered in the previous presentations, would get that the rate of growth of admissible values is exponential. And this is a fundamental problem of symbolic analysis, that it has an exponential growth rate. If it is more pleasant for some to hear it this way, you could say that symbolic analysis has an exponential number of branching options. It's the so-called path explosion problem, and in a certain sense, nothing can be done about that in a general case, and we're trying to fight this in some specific cases. So at this note, I congratulate you on getting through the first part. And now we are about to embark on the second part, where we'll try to get this problem solved another time. In order to speak the same language, we need to recall certain terms. Variant is a pair, y and x, where x is a certain value and y is a certain feasibility condition. The variative set is the set of all the variants of the expression. Let's now see how expressions are built in symbolic analysis. Imagine we have a certain expression G and it has sub in expressions. Because of symbolic analysis, these expressions can be variative with their variants and values. These conditions and values can also be expressions with sub-expressions. And we get to a recurrent definition of what an expression is. This is an expression with sub-expressions where each of these expressions is a variative set which has conditions that are also expressions. And it goes all the way until all the expressions contain variative sets. So in order to get a specific value of expression G, we need to fix some variant, take its value, recursively get its admissible value, and then take a condition or constraint for this value and get the variable, the admissible value for it. But let's take a look at the schematic. We'll understand that for one's admissible value in the fixed value of the variant, we have an entire set of admissible values as conditions of this admissible variant. In other words, the number of admissible variants is growing much faster by conditions rather than by values. And here we get a lawful question. Okay, how can we fight these conditions? How we can reduce the number to mitigate the growth speed? Before fighting the problems, let's take a closer look at our enemy. We have a small example, accepting a number of parameters. In the body of this function, there's a branching construct. So let's take a look. Quite often, the conditions for this construct is a set of conjunction and disjunction that contain expressions based on these theories. Of course, there can be some negations there, but for the most part, this is a set of conjunctions and disjunctions. This is about the way they look. And now you have a question. Okay, they look about like this, but how can we store this in a program's memory in symbolic analysis to work with them? Here we'll make a step aside and recall and maybe recognize, if you haven't known that an abstract syntactic tree is an oriented tree, the nodes of which are operators and the leaves are operands. And once again, for this logical expression, we get this abstract tree, semantic tree. Recalling you that an abstract semantic tree does not have parentheses, does have brackets. So take a look at this tree. Actually, it's one of the variants of storing a condition in the memory of a program. Let's write it down in a more formal way. What do we have? We have a certain binary tree that can be of two types. It's either a leaf, where the node is some expression that we get, or it's a non-terminal node which has a type of operation, conjunction or disjunctions, and also possibly it has left and right subtrees. But what advantages and drawbacks this variant has? Firstly, is the compactness of our storage. We use a limited amount of memory to store this information. Second, the determinated character for the same formula will always be getting one the same abstract and, in this case, binary tree digression. This will be enforced if we have a determined grammar. Unless if we don't have it this way, we'll make it be that way. And so we'll also have an obvious thing. We'll have the recurrence of code. All the operands will be repeated in going through this binary tree from left to right. But unfortunately, the big drawback is that the speed of search in the binary tree is extremely low. In the worst case, when we have a case like this, we have a linear search speed, and unfortunately it makes our life really hard. So let's now go from a binary tree to the binary search tree. So for this, we reshape our tree. Firstly, we add a key to the leaf, and this key will be related to our expression. And then we, in non-terminal nodes, remove the operation type and carry it out of our binary search tree. And instead of it, we'll add some expression that we'll be looking for. Because we get expression in non-terminal nodes, we'll also add a number key for which we may run a search. Therefore, we've done two things. We've said that this binary search tree contains operands specifically for a specific type of operation, conjunction or disjunction, and that we have added the number key of a search related to the expression as part of this tree. In these keys, we want to implement one simple axiom. For two equal expressions, this key should be the same. So what's the key for these? So what are the properties of this tree? Of course, it's still compact in terms of storage. But as to deterministic character and repeatability of the code, it completely depends on how this number key is calculated. The search speed has grown a bit, but we're still a special case when this speed can be linear. Okay, the binary search tree is not a very good fit. Let's try self-balancing search trees. These are the trees that automatically maintain the height minimally possible with certain operations, insert or deletion operation. 1 second, and now you see some kinds and representatives of this family. And another digression. Today we'll have a lot of lyrical digressions, so once in a while I've decided to speak. So for instance, black and white trees, up until a certain point in time, they were used in the cause of operating systems of the Linux families to build virtual address space in the processor and virtual ranges as part of it. The B-tree families are used for indexing of the databases. AVL trees are used in the organization of certain unchangeable data structures. That was a digression, but actually all these trees can be split into large groups by one criteria. Those that are balanced in height and those that do not guarantee the height balancing. So the trees of that group tell us that their height will never exceed a certain logarithmic value. In terms of red and white trees, red and black trees, it's an algorithm of 2 elements. In case of AVL trees, is 2.5 of the number of elements, and L3 is a logarithm on the base of k. Of the number of elements. The second group also tries to balance the height, but it doesn't guarantee that the height will be lower than a certain logarithmic value. And in certain cases, this will lead you to a linear height. So there's a probability of such cases to happen. So we'll try to operate with self-balancing trees, balanced in height. Let's just, for simplicity's sake, call them balanced trees. This slide shows different advantages of the approach. Having closed our eyes, we can say that they're compact in storage while we're closing the eyes, because the guarantee of logarithmic height does not come for free. You need a certain number of bytes, information bytes, to that height. In different trees, it can be calculated, but nevertheless, the determinability and repeatability is also depends on the case, but the speed of search speed has grown. As alternative, we could take a look at the hash table, where for each expression, following a certain hash function, a certain value, hash value value will be calculated to become a key in the table. What are the advantages of this option? Again, closing our eyes and putting our hands on the heart, so we can say that the compactness of storage and the search speed are quite good. They will depend on how good the distribution is for the hash function that we've selected, and also on how collision problems will be solved based on open addresses or on lists, or how we implement that. As to the deterministic character and repeatability will depend on the hash function that we've selected. Okay, so we have been reviewing all these different options. So why are we selecting a structure that should provide for a fast search? Actually, for this, we want as early as possible to reduce the conditions and to understand if the solution is achievable even before we start the analysis. Okay, can we use anything else? The next element that we can use are polyadic operators. These are operators that has an arbitrary number of operators. They're also called multi-R, n dimension, and others. But we'll be using the term polyadic operators, and we'll make the following horse move or knight move. I will take a condition, in this case a conjunction of n conjuncts, so it has n -1 conjunctions, and we transform it into just one conjunction, which will include n operands, and then we'll be working with conditions like that. They said, of course, we'll have to adapt our data structure for this process, but because this is just a small wrapper for the sake of convenience, and we won't dwell on that. Okay, what else are we going to use? In actual fact, we can use the property of a mathematical model. It's Boolean algebra. We're not going to get into what Boolean algebra is, what advantages it offers, but if somebody's interested, Boolean address is a distributed mesh, and we can discuss that. But here, we are interested in very simple things. What properties this Boolean algebra has, this data structure, and how we can use them. So this slide shows these property, and let's take a look what they can give us. The idempotentiality. It tells us that if we have some operator with repeated events, we can throw them out. This says that in our data structures, we can remove all the repeated elements that will save the memory and boost the search speed. Then this thing says that we can work with the supreme says that we have a conjunction of several operands and conjuncted with several true expressions, will always be getting a true expression because there doesn't exist a false expression for that. In the first case, it was the injunction, and the same for conjunction with negation will always be getting a false expression. The immersion says that again we can improve the search speed. Supremum and infimum tell us that in a variative set we can fix one option and throw out all the rest. So in symbolic analysis, we'll fix one execution path and throw out all others, which reduces the total number of time of work and of operation, mutability, and also sociability. Sociability, together with some polyadic operators, gives us a small bonus. Having some operand and applying a certain operation, like conjunction with conjunction, we can take a current polyadic operator and add a new operand as part of it, because our polyadic operator can take any number of operands, and nothing stands in the way for us to expand it. And now the distribution capability. It says that we can open up the parentheses to get some presentation. This is the only property that doesn't offer us any advantages either in memory or in speed. It can just be used.
Мы с вами разобрали свойства булевой алгебры и то, как мы можем их применять.
This is about all.
Я вот сейчас увидел
Oh no,
решение и понял, что
I see the explanation mark.
свойства булевой алгебры
I understood that we forgot Boolean algebra property that relates to the operation of negation. Let's take a look at them. Involution, double negation, we can remove that and just bring the memory down a little bit. The additivity is
будем получать истинное. Аналогично для
states that we'll always be getting a true expression in this case.
которая
This is one of the properties that allows us fixing one variant in the entire variable set and considerably grow the speed of search. And De Morgan laws allow us changing the order and sign of operations. This is the property, just as distribution property, that does not offer us any gain in the speed of memory, but it allows us operating. I hope the developers are here in this room, and we as developers quite often write a lot of code that has constraints or conditions. Even when we send calls to the database, requests to the database, it quite often happens that compilers and databases don't often work very well with optimizing these conditions. And if we if we recall these properties, we may make the life of compilers a little bit better. Okay, coming back. So we've talked about the properties. We have databases. We have the operators. We're trying to bring these all things together. But this whole data structure starts standing in the way. We chose a data structure so that it should be about the search of the element that we need. But Boolean properties also require a fact to check if the negation is also present. And as a result, we get a situation that in order to apply Boolean properties, we need to run two searches instead of one. Okay. Of course, we would like to optimize this somehow. What can be done as one of the options? It doesn't make any difference what kind of data structure we're dealing with. It's what the important fact is that the search is run on a certain number value. So let's be imputed enough to add a certain variant. So these values for the expression itself and its negation should be the same. So we'll make our distribution a little bit worse, but what will it give us? Instead of an operation equal to two searches, we'll just run one search operation with the return of values from the data structure and compare it with the expression that we're looking for and with the negation of this expression, and we'll get the number of operations equal to a single search, and maybe a two operation of comparison that would be considerably lower than two search operations. Okay. Clicker. Okay, we've run through a lot of things, and then you have a question. Is that all? Can we just wrap up and leave? Actually, no. After all, our transformations, the conditions have very different look, and we need to take a look. We have normal forms: conjunction normal form and disjunction normal form. Conjunction normal form is some conjunction where each operand doesn't contain any other conjunctions, other disjunctions or negations. And same thing for disjunction normal form. There's a theorem saying that any logical expression can be reduced to a normal form. Well, unfortunately, we're not going to prove this theorem right now because the time of the presentation is very limited. Instead of this, we can look at what steps we can make. So as we reduce the logical expression to a normal form. If we take a look at the properties, these are just the properties of Boolean algebra that we have discussed. And for your understanding, let's take this logical expression and reduce it to a conjunction normal form. First, we apply the De Morgan form, then we apply other properties to get the normal form. This is the normal form with which it is convenient to work, and more than that, all the solvers I mentioned in the beginning of our presentation work with this. And here you may arrive at the most important question that's printed. And Georgi, why have we done that? If there are SMT solvers, we can just take a condition, put it into an SMT solver, and get fun from life. The answer is, as always, very simple, and it's reduced to one symbol. Oh, optimization. Let's take a look at the mouse. Telltale example. Okay, click it on. Fail me. CVC5 1.2. On the left, you have the large parameters of this SMT solver. And in the center, you see the expression. So under these conditions, this expression doesn't offer a solution after dozens of minutes. After that, I just stopped waiting. Let's take a look closer. At the end, we have some terminal operator that does the following. If the integer equals 0, please return 0. Otherwise, return the value of dividing 0 by this variable. So it always returns 0. And if you explicitly put it into this expression, turns out that there's an expression, the solution, and it finds the solution in just a few seconds. So if you explicitly set this condition, it will solve very well. Another example, we have a system of 5 equations and 4 variables, four unknowns. SMT can't solve this problem in dozens of minutes. And the solution is in the range between 5 and 20, I think. Okay, what can we do? So we have another represent, Z3 4.14. So SMT can't solve it for dozens of minutes. And in a couple of hours, I wasn't able to get an answer from it. Okay, CVC5 in 3 hours. Okay, YSys 2, 6.5. Which quite often gets prize places in SMT contest. It also can't solve it in dozens of minutes. And the first solution, because we have more module here, is in the range of about 100,000. Then you have this question, so there are SMT systems, and so why can't they solve? Why is it all so bad? Actually, the answer is extremely simple. SMT belongs to the NP-hard class of problems. So in the general case, in order to understand whether the solution exists, so whether the statement is derivable, you require the time not less than exponential. And as a result, you get a situation that symbolic analysis has the exponential growth rate. SMT is exponent times exponent. Absolutely unacceptable. So one way or the other, simplifying conditions either for SMT or for compilers or for databases is required in order to make the life of our colleagues a little bit better. And so we are gradually wrapping up. So what has stayed outside? We haven't considered the algorithm of solvability that are used in SMT solvers. We haven't considered the SRL. We haven't considered local stochastic algorithm. We haven't covered the Howard's logic or Howard's triplet that's used for verification of certain conditions in software. It's also used in the derivability analysis. We haven't used the BDD and all kinds of its modification, that simplified binary diagram and multi-terminal binary diagram and so on and so forth. And of course, we've only considered basic normal phones. We didn't consider all the variations, but I hope you understand that the time of presentation is limited and you can't fit everything into one presentation. So therefore, it's just a presentation of a whole series. The third installment in the series. So you can use this QR code to come to the presentation, leave your comments, and also to understand how the organization of our track is happening. With this, I would like to thank you for being with us, and I'm prepared to answer your questions. Georgi, thank you very much for this presentation. And apart from us calling on everyone to use the microphones to ask questions, I would like to remind you that leaving feedback for the presentation, you get an opportunity of winning the book of incredible Lovelace and Babbage.
Меня слышно, да? Замечательно.
So we get the question. You can hear me. My name is Konstantin.
В том числе формальной верификации по работе.
I'm also into formal verification by way of my work. In all these solvers, I have found one trait. You never know. And even in your presentation, you said, and I got tired of waiting and pressed Control-C. You know, some problems are solved immediately, and in some cases, you have to press Control-C. Sometimes after a couple of days of waiting. Your best practice. What's your best practice? How do you decide how long you're morally prepared to wait? It's a good question. Put it this way. We use different SMT solvers. This includes a moment when we used our own custom SMT solvers that met the declaration. And so we have a very simple policy for the limitation. This is limitation in terms of the size of memory, number of operations that they can apply, and also one on the time of operation. I won't be able to give you an exact number. It's under NDA, but the time is quite low because we work with a lot of expressions in symbolic analysis, much lower than the one I mentioned. I hope that I managed to clarify the situation for you.
Кажется, вопрос не закончился.
I think we run out of questions. And Konstantin, again, I left the microphone too earlier. So, yes. But look, then you will probably have been very upset because having waited another moment, maybe you could achieve that. Unfortunately, there are situations where you have waited for 100 minutes and then in minute 101 it would have solved. But by the number of the variables, you can't always realistically predict how long the SMT solver will take. If you indicate a specific theory based on which the work is done, the SMT solver may start working faster. If the logic is not known, in these cases, you have to expand the class of theories being used. And in this case, SMT will have to enumerate a larger number of variants. So unfortunately, that's just a fact of life.
все еще
Dear friends,
вопросы за
I'm still calling on you to ask questions. We're awarding a book for the best question among those who are with us in this room. So far, we just have one leader. Your chances are high. Hello, my name is Alexander. I'm also interested in SMT solvers. As far as I understand, in your product, you used some prior optimization in order to feed the results of this optimization to SMT solvers. Why don't you add some open source optimization into the SMT solver to share your work with the public? It's a good question. Actually, two answers. Answer number one, quite often SMT solver try to apply these optimizations because one way or the other they work either in the normal form or with different binary solvability diagrams. But unfortunately, they don't apply all of them because they have less information about the field. So the field is known in analysis much better than SMT. That's one reason. The second reason why we use this, you have to take all the optimizations, put them as part of the solver, wait until it's solved, until it's accepted, and because most SMT solvers develop in certain universities that are located in certain countries, I'll be quite cautious saying that you may run into some problems. And quite often we report some cases in the use of SMT solvers that certain cases don't really work. Or if they had worked okay in the previous version, under this version, everything is broken. So these are the two answers. I hope I'm making you happy, Alexander. Hello, my name is Fyodor. I have a question. What's the space for using heuristics in SMT solvers? Oh, it's a good question. I'm not going to get into details because the topic for a separate presentation. Maybe I'll do that in the future. But one or the other, in SMT solvers, solutions based on enumerations are solved. Use typical algorithms, Dorfman, Kupin, Livanov, if I remember his family, and DSL and stochastic algorithms. This is an algorithm that fixes some value of the value, the true or false, and based on that tries to use different reduction procedure to derive some expression. If we get that, everything's fine, we get the expression, but if not, here all the differences start. We need to change some solution based on the current result. And here we're getting into the area of science where scientists try to understand what kind of approaches can be used. For instance, statistical algorithm, the return happens as a DSL algorithm. Conflict is defined based on our choice, and based on the type of conflict, the replacement of single space disjunctions is happening with subsequent verification. In stochastic algorithm, randomization is applied based on the current result, and putting it bluntly, some transformation is used. So the solution is transformed into a number-based function. So in a general case, it looks about like this. Hello, my name is Maxim. I have one comment and one question. A comment to what one of the previous colleagues said, how long we're prepared to wait. This is basically a stop problem. Alan Turing formulated it. It's solvable. And a question. As I understand, solvers yield an accurate answer to the question with a 100% guarantee. What about the probability? Let me comment. Let me explain. This problem
решается по-разному. Например,
is solved in different ways in different projects. For instance, antivirus products need to give the answer in a very short time regarding whether the program is dangerous or not. For this, they enumerate all the branches of code. They do it fast, but do it without the guarantee. What's your opinion on that? A good question. I'll say a couple of phrases. Phrase number one, it's fuzzy logic. It's an area of science of dealing with what needs to be done when you don't have a clear understanding of the situation. What's the specific situation in our case? Everything is absolutely simple. We apply these approaches in certain cases because we can't guarantee that it's a solution, but the solution of a system, one way or the other, is needed for the user to validate the understanding whether they have vulnerabilities or not. And this way, you can just mark that they have a certain probability of a hit without a certain guarantee. Thank you. Then the second part of the question, how about making two-phase analysis? Phase one would be look for the probability. I think you understand what I mean. A good question, a simple answer. Well, to a certain extent, we have this. Dear friends, we'll be able to take one more question if you have it. I'm actually a bit struck. I would like to dispel one of the wrong statements by the previous person. It's not a deterministic question, deterministic thing. It's a Turing computable problem. Okay, let me correct everyone. It's an NP full complete problem. It's solved in some polynomial time. There's a class of NP hard problems that are solved over the time, not less than exponential. SMT solvers belong to NP hard problems. So what we're talking about here is that we're trying to understand, there's some source code, we're analyzing, are we going to complete it analysis or not? The thing is that all the different constructs are feasible, not only Alan Turing, but there's also Rice Ethereum saying that without, well, it's a separate topic of a presentation, I'm not going to open the cards. So without any additional actions, we won't be able to understand whether it will stop in a general case or not. So to be as formal as possible, these things look like look-alike, but stay somewhere on the side. So, any more questions? I'm prepared to take them. Okay, I think that we've run out of questions, which means that it's about the right time of choosing the one who gets the book from the Peter publishing. Just one? One. A good question. Actually, I am divided either to Peter or to the person who asked about what we do with SMT probabilities. Let it be Peter's question about the solvability algorithms. Peter, come to us and we'll hand you your gift. Georgi, thank you very much for your presentation, dear friends. Please don't forget to leave your feedback for this presentation. Okay, thank you for having joined us, and I wish you all the good time at the Positive Hack Days Festival. And so we're going to have a very, very short break of about 5 minutes, and we'll continue talking about optimizations. Please stay with us.
Всем привет! Мы продолжаем наш трек, и следующий наш спикер — это Владимир Ярославский, и он поговорит о оптимизации. Владимир, приветствуем тебя!
Спасибо.
Hello, Vladimir.
Итак, всем добрый день. Меня зовут Владимир Ярославский, и
I'm
поговорим
Vladimir Yaroslavsky.
о код.
We will talk about productive code.
Есть. Буквально чуть-чуть о себе. Начал я программировать еще в прошлом
I started to
Мой любимый язык
program
это Java.
last century. My favorite language is Java,
Версия была 1.01.
and the first version was
И
1.01.
добавил бы то, что моя система
And
используется в NetBeans, есть такая
my
для разработки, и моя
my printing system is used in NetBeans,
также в Android. Ну и, кстати,
and my sorting is available in JDK and Android.
если кому-то будет потом интересно,
That's my email if you would like to contact me.
в конце доклада я отвечу на ваши вопросы, и
At the end of the presentation, I'm going to answer your questions,
организаторов, и от меня тоже.
and best questions, they will get prizes.
Сейчас я работаю в Сбере, в команде, которая
I
разрабатывает
work now in Sberbank. We are doing a Giga IDE.
производительный код. Ну, давайте
What is good
там читаем.
productive code?
Дизайн, но это все
So
человека.
good code is readable, clear.
Правильно, если он
That's for the
выше
human, and it should work correctly.
того, что он работает правильно, очень важно, чтобы он
And in addition to being
не хочет ждать по 2 минуты,
right, it should be
3 часа.
it should work as fast as possible. No one wants to wait for
Которые тут будут, они там проведены
several
но большинство
days or hours as at the
языков, так что надеюсь, что всем будет
previous
интересно.
presentation. We are going to talk about Java, but it is applicable to all other languages.
Будем обращать внимание, когда говорим именно
What we're going to focus attention when we will talk about productive or
размер памяти,
fast code.
какая сложность
It's the size of memory,
возможно, глубина
algorithm,
но сейчас
complexity,
про время исполнения,
the number of flows, and time of execution. That's what
мы затронем
person really feels. We're going to talk about
строки, математику,
strings,
числа и целые, различные математические трюки, коллекции,
math,
ну и так далее.
algorithm,
Параллелизма. О чем мы говорить
algorithms, and parallelism.
мы не будем говорить,
What we're not going to talk
чтобы они работали
is how to tune databases,
системные настройки.
operating system,
То есть это все
interaction system,
даже без этих
properties,
реально можно.
and even without this optimization, you can improve your code.
Если мы хотим понять, как же
If we would like to understand
можем взять
how our code works,
профайлеров,
we can take one of the profilers
которые часто
and find a hot method which is frequently executed and which is instrumental in execution.
приложения в консоли браузера,
If you have an application or browser console, you could look at the time of your query execution
что быстро.
and to see what works fast and what works long. How to measure time. In Java there is system.nanotime.
Очень удобный tool GMH.
There is very convenient tool GMH, Java Micro Benchmark Harness, written by Shipilov.
Языки, то тут тоже
As to other languages,
там C, C++, соответствующие
C, C++,
утилиты,
there are
ну и также всякие системные.
applicable profilers and utilities.
Но какие есть особенности, если мы запускаем
So what are the
Java?
special things that we are launching this program in Java language? So if you'd like to measure
Его как-то заполнили,
number sorting,
включили время,
if we have an array,
отсортировали,
to look at the nanotime,
ввели на печать.
and we can sort it and then we can print it.
Сколько-то там наносекунд выполнялось на
And
и потом
so many nanoseconds,
время, но
our sorting was done.
это правда.
Would that be correct?
Усложним наш
We can
и сделаем
make our scenario more complex.
их несколько раз.
And we can make these steps several times. We prepare an array, sort it, prepare array, sort it. And if we look at the result, we can see that first the number is bigger, then it's lower, and then it's balanced or stabilized.
Java у нас
Why it happens?
bytecode потом
Java compiles bytecode, bytecode is executed, and there should be time for stabilization so that JIT compiler would optimize bits of code, and so each iteration gives a different result. In order not to think about all of this,
tooling, GMH,
there is tooling available. GMH has thought about this already, that we need to run it several times and use the average value. So we can do that through the library, and we need to do the test. The test is written very simple. There is annotation, how many times we want to warm up our code, so many times to launch so that JIT compiler would optimize it, how many times, how many iterations, and then if we have a method, we note it as at benchmark, and if we need initialization, there is a notation setup.
Минимум кода, да, для того, чтобы
So minimum code to write a right
скажем так,
test.
на логике теста.
So we are focused on the test logic.
Запустим, и вот он выведет.
And if we launch this and give the statistics, at first we do 4 warm-up iterations, and then 4 iterations which would be launched to measure our code. And here you can see that for warm-up, these iterations take longer time. When we launch and we're saying that our code works so many milli or nanoseconds, we need to specify the context, at least the version, GDK version which you use, because from version to version, Java is improving, like sorting started to work faster, and strings are concatenated better. And in order to do some statistics, you should at least specify the number of your version. Let's talk about strings. In Java, in order to sum up 2 strings, you can use plus or plus equals. For convenience, very small code, very convenient. You can take any book, like concatenation of strings. You shouldn't use, but you should use string build. Everybody knows this. However, it's always interesting how slower or how faster it is. A simple code, we are adding a litera 10,000 times for this char, for this symbol. The difference is more than 100 times string builder works faster, because plus string, a new object is created. In String Builder, only literas are added, and the string is accumulated. Array list and linked list, they always ask about these 2 collections on interviews. There is array, and as to linked list, it's the 2 linked list. We can add something to the collection and to read something. Use array list. Linked list is bad, but how bad it is and in what cases? Let's add elements to the end. And if we add elements to the end in array list, it's when it's full, we just reorder the assay array. In linked list, we make a node and tie it to the end. So the time is more or less the same. Linked list is a bit smaller, longer, because we create a node and its creation of an object takes time. So they're comparable. Now we add elements to the beginning. In linked list, we make a node and tie it to the beginning. If we want to add it to array list, we need to free first place, so the entire array, move it to the right. And that is an extra action. Everything happens natively. However, linked list works 40 times faster when adding an element to the beginning. So in that case, linked list is cool. But let's compare it again. If we add elements to the middle, standard cases, beginning, end, and the middle. If we add it to array list, we need to move half of the array. If we need to add it to the linked list, we need to find that place, the index where we need to put the element. We need to run from the beginning or to run from the end. That is an additional action. And what is faster? So we can see that although array list we need to move an array, but to search for linked list, run this list is 20 times longer. So that's the table, and linked list is losing when adding to the middle, but if we add only to the beginning or the end, then it's quite good and could be used. There is also array deck, which has two methods, add first, add last, and they are working a bit faster. So linked list is popular mostly during the interviews. So we've added elements to the list, but we add elements sometimes, and sometimes we read them. So if we are to measure how much time it takes to read elements, the first, last, and the one in the middle, the reading for array list is a bit more or less the same, because indexing is not important. It's A in it degree. And in linked list, we need to read from the beginning or from the end. And in that case, reading from the middle is many times slower.
Таким образом, если у вас используются какие-то коллекции, да.
So if you have any points are not vertical, second case is because the points are too close, and the third example is what we need. So we need to determine those cases.
То есть мы решаем две задачи.
So we solve two tasks, whether the points are far from each other and whether they are on a vertical line, almost vertical. First, we recall geometry, that there is a distance between 2 points. The sum of squares, and we compare it with a constant. Is it more or less? So let's look. We don't need to know the exact value, the distance between these points, but whether they are located far. So we have a Boolean answer, yes or no. And so the radius of numerative answer we get a substantial number, but the answer is wholesome number. So let's separate this square and compare it with a different constant. So there is no material math. Are these 2 points on an almost vertical line? That's the second task. The error margin could be 7 times 7 degrees. So sinus is the catet and the hypotenusa. So we're looking for the distance between these 2 points and comparing it with the sinus of 7 degrees. Sinus 7 degrees we can have calculated, and then it becomes quite difficult. What to do? Can we make it more simple? So we recall geometry. In addition to sinus, there is also tangents. And what is tangents? It's catet relation. It's like modules of distance between our points. So we can write this as to the math, it's the same, but as to calculation, it's much more simple. So we are going to have material. So we need not only the degree in real division, but we need to identify whether this line is almost vertical or not. So what can we do in math? We can do equivalent conversion. We divide it by tangents 7 degrees, so we don't have division, x by y, but we have 1 divided by tangents of 7, which is almost equal to 8. So in our case, we can relieve this formula. So what happens in order to understand whether these 2 points are close to each other and are they on the vertical line? We need to calculate these 2 conditions. And it's good we have wholesome numbers. No real math, no real calculus, but we need to optimize it for the integers, so that we can allow this margin of error. So A point and B point, and there is this circle. The B point is on top, and we're interested in this red hemisphere, and they're almost vertical to B on this arc. So we can replace our circle with a square. We can replace the arc with a straight line, which is more simple than arc. So that B point is out of square, quite far from A. We need to write the second condition. The difference of x on module is bigger than this minimum. These would be points outside of the square. Then it's more simple. You don't have to do something with those squares. Can we simplify it again? Because we're real programmers.
Вот давайте
We
посмотрим.
need to simplify it to the end.
Первое сравнение это
So the first comparison is the
вот то, что
difference of
соответствует точкам, которые
x with the minimum.
синими линиями.
This is
Когда у нас точки B,
painted by blue lines.
они будут
And when the B line is almost on a vertical line, it would be on this green area, and it would not cross the blue blue area within our sensory screen. So the first condition we can remove.
мы получаем вот такую
And then we are getting this
простую
very simple formula, very simple condition compared to what may have been at the beginning when we were doing this straight. So as to geometry, this is the first condition and it's correct, but as to optimization, we always need to think about the task conditions. And if we make a measurement, the formula should be faster. So the difference is 2.5 times. Now let's talk about algorithm tricks that you can use. If you have an array and you need to determine its length, if you need to take 1/7 and you need to divide it by 7 or take some kind of a ratio, so you need some kind of a real number. And we turned it into the real calculus.
То есть делая арифметическую, вещественную арифметику, а вот
and making this real calculus, we are getting the integers, because the indexes in an array are integers. So how can we optimize it? The most simple method, let's turn this real number into 1 divided by degree of 2. So we can approximate 1 divided by 2 in k degree is to move it in a certain number of bits. So we do this using simple approximation, cheap approximation. We can make our arithmetics. So you can see the difference. It's not much. It's 1.4 times. However, next,
посмотреть на, скажем, там внутреннюю реализацию сортировки,
the internal realization of counting sorting. Using an array, we can calculate the number. And if we sort short numbers, they could be negative and our index is positive. Then we move it by 32,000. And then we get an array from 0 to... And we can make it faster. We can make a different mapping using logical, using this mask. So we're going to get positive numbers and this mapping, but it's going to work faster. So the difference is almost 3 times. If we're using bit mask, if we have several logical Boolean values, we can use Booleans or bits, and using certain manipulation, applying masks, we can calculate those logical operations. Example, when we can use it, if we have some transport, if there are jets flying on certain days, and we would like to have a timetable on which days the jets are flying. We have 7 days in a week, so we can use 1 byte to store this information, and 1 reserve bit, the 8th bit or 7th by index, we can use to indicate whether it's summer or winter time frame. So to know whether it flies on Saturday or Sunday, we can use this formula, or it could be different formula when you compare those masks. The difference here is not much, only 20% gain. However, sometimes it's more convenient to read the code and to store this into the database, so you can note it. You can determine the degree for 2 is n number degree of 2, so we're moving from right to left, and when we find this 1, we need to understand whether there are 1s further, whether the number is 1 or not. So it's quite simple cycle, more or less clear. I believe that everyone can manage it, but we can determine it without cycles, without if, just by this formula, n minus 1 multiplied by the number n. And we compare this with n, because n is not as a degree of 2. And before making any calculations with bits, most probably there are optimized algorithm tricks. The difference here is quite interesting, 1.5 times faster. As to algorithms, there are a lot of algorithms, such as sorting. So if in a certain code you are using sorting by insertion, you can use pair insertion sort when there is not 1 element but a pair already. Or you can use merging sort or a hybrid to sort almost sorted data. And if you have, if you are sorting real numbers, it's better to use radix sort for big arrays instead of quick sort. Types of data. We all know that in Java there are primitives as well as in other languages, log, int, char, byte. In Java there are wrapper objects, and many do not understand what it means, and they are using them. They are using log, boolean. So it has each primitive has its wrapper. So if you don't know why you need to use a wrapper, you can make a primitive. So, to quote the difference, I've taken 60,000 numbers, applied them to different sorts of data and sorted them. And sorting a list, as we mentioned, works much slower than sorting arrays, because the list is first converted into array, sorted, and then converted back into list. Sorting of objects is much longer than sorting the data, because there is team sort used, there are objects, and there are huge costs.
Потому что используется сортировка подсчетом, и она быстрее, чем quicksort, но на определенных размерах. Поэтому, если в вашем приложении вы часто используете, сортируете ваши
application uses data sorting quite a lot. Take a look at the type, and maybe just through the change in the type of data, you'll be able to improve the performance of your application. Now, parallel computing, talk about Java. There's a very cool package, java.util.concurrent, that has a lot of interesting things. And if you need to parallelize something, you define one method for compute, then write business logic, and the rest is taken up by Java itself. For instance, we have a problem. We have an array, and we have a method processing some range. So if you take a look at a classic solution shown in academic books, what do? If the range is not very large, we don't run any parallel computing, we just process the data, and then we split our array into parts, and on parallel, we process the left and the right-hand part. So it's a simply looking algorithm, easy to understand. The problem is that in invoke all, mainstream will be waiting until the other two will be completed and will not be doing anything. And that's not optimal. To fix that, we propose a different schematic. So we do class mytask extends computer completer. We run in parallel the processing of one part, the right-hand one, and then we process of the right hand in the cycle. And if it's small, we just process it after the cycle. And in this case, the number of threads will be just half of those. The lower the number of threads, the better. So even this parallelism can be written correctly and incorrectly. Same. Now that we've started talking about parallelism, there are lots of classes in Java, different implementations. I need to read the Java doc in order to understand what they're intended for. Don't use multi-threaded version for a single-threaded application. So you can use it physically, but that will be very inefficient. So, for instance, release is in a array list in single thread implementation, copy and write array list in a multi-array implementation. You see the difference in performance is quite considerable. It's just something you pay for synchronization. If you don't have parallelization, then why do you need that? Now, about SQL. Imagine we have a table with a tree-like structure. We have some parents and children, and we need to output information about the top level parent, including the node cells. How do you do that? You specify the node, indicate the ID, and select from node where this ID is ID. Then you do parent and run the cycle. But the essence of working with databases is such that you should try to get all the information in one call. In SQL, you do it in a very simple way. There's recursion, and what we've just said can be written this way. As a recursive select, that will give us what we want. And that would entail just one request to the database. So and the gain will be quite considerable. Another example from life experience, we were developing a platform. There were different data models there. And from the viewpoint of the bosses, well, they said it's bad, it's not extendable, and you need to implement just one, a universal one. So what's said is done, and how was it supposed to work? We have just one element, and we need to take its children. So in a system, there's a list of providers. We take every provider. We tell it to give you all the children of this element. It issues you a list. We collect it all together and get an answer. Everything seems to be okay, but when the entire functionality was migrated to the platform, it started to work very slowly. So for a last test project, it would take 55 seconds instead of 5 seconds. So what was the reason? Well, they started optimizing it, looking for the problem. What was the essence? They built a platform, the MVP, minimum value product, registered some providers. Everything was flying very fast. The bosses were very happy. But they didn't run load testing. So they should have started 2,000 providers and to take a look at how it was working. And here we arrive at the topic of testing. Firstly, you need to run unit tests for correctness. That's a must-have. You need to run performance testing, benchmarking. So if we have done some implementation compared to a previous one, we need to check if it isn't working slower. You have to do stress tests, smoke tests, and write tests for every bug. You also need to remember about test coverage. Yes, you can say that you have tests, and then it turns out that the coverage is only 10%. You need to keep coverage not lower than at 80%. And also, now that we've talked about Java, you need to take a look at languages. Regarding performance, firstly, choose the applicable data structures and algorithms. Experiment. Look where it runs better. And if it runs worse, try to understand why. Read books, browse the internet, find algorithmic tricks. And by the way, there's a book with the same title. You need to write tests. Please raise your hands those who don't like writing tests. Okay, who don't write them at all? Who doesn't? We have some hands. Hey guys, please ask your colleagues so that they should write tests for you. They will be happy to help you. Also, I have to remind you that programming is not exactly maths, and you need to take account of that as well. When you're given some problem to solve, to define something with 2 dots, you need to look as deeply as you can, trying to optimize as much as possible. Thank you for your attention. Over to your questions. Vladimir, thank you for your presentation. Dear friends, please don't forget to leave your feedback for Vladimir. And we are going to have a prize for your feedback. We'll run a drawing. And now we have microphones in the aisles. Please come up to them and ask your questions. We also have gifts for the best question. That will be a book from the Peter Publishing House. And also Vladimir brought some of his own gifts. Yeah, just a minute. If anybody of you has examples from your experience, how you optimize code, please give me, you've seen my email address, please write me. Hello. Firstly, thank you for your presentation. I use some of your practices myself. What's your name? My name is Dmitry. I'm sorry. So the optimization of the known mathematical formulae in real programs sometimes turns into a guilty pleasure. There's nothing left of the original formulae, and in some cases you can't even understand what's happening. There are no comments, no explanations. And there's some approximated formula that you don't have an idea what it's doing. And you've also given an example. Let's simplify, and then you've got nothing left of the original formula. So how much do you encounter this line in your real life? Well, it's very dangerous to do that. And from my experience, I would say that if you have the code that doesn't have text or description added to it, you don't understand what it's doing, write this code from scratch again, and that will be much more useful for you. You'll have the comments, you'll have tests, and most importantly, you'll know how it works. It's much better than trying to understand how someone else's code is running if you don't have full understanding. Well, maybe it's not the right approach. Sometimes you need to find the author, but in certain cases, even the authors have forgotten why they made certain choice. So if you don't don't understand the codes, do it yourself. Redo it yourself. Well, the bosses may not like it, but what else to do? Do it as a secret from the bosses.
В основном говорилось про
Hello, thank you for the presentation. In the presentation, you were talking about the optimization of the medium execution time. Have you had experience fixing some spikes? Like, for instance, when the release is checking a certain array, some single operation will be showing very bad results with the average execution time being quite good. Well, I haven't had situation of that in my experience. It's either working well and everywhere, and if it works slowly, then it's more likely to work slowly everywhere. But if there's a spike for some special case, well, for instance, if we run on a virtual machine and it may have worked slower because of that, but I personally haven't had problems like that in production. Thank you.
Владимир, спасибо большое за доклад.
Vladimir, thank you for your presentation. My name is Georgi. In the presentation, you mentioned a phrase that's quite close to a lot of us. We're programmers, and let's optimize. We're programmers, let's optimize, and again. In your experience, how were you able to stop this process? What was the moment where you understood that it's time to stop? Well, look, firstly, I didn't say that it's not that we're programmers, and there's a certain test how to determine if you're the real programmer or not. If you're interested, come up to me, and there's a test. But we were looking at if either the boss would come to you and ask you, look what you're doing, everything used to work, and what you're doing now. And the second thing was stress testing. There are some empirical rules, so you should exert the load that is 4 times as high as the expected one and see if everything works okay. That, I think, is the basic rule of thumb. I was talking about JDK sorting. Well, I guess I won't be able to optimize it anymore because it's been working for 4 years now. But I mean, everything has changed. Thank you.
Добрый день, спасибо за доклад.
Hello. Thank you for your presentation. My name is Alexander. Georgi asked the question I had intended to ask, but there's still a small part left. You were talking about the criteria for good quality code. It's not enough that it should be formal, it should be working correctly. This indeed is must-have, but it should be readable. It should be clearly written, especially for those people who come after us. So where again is that brink, that line? So, for instance, you join a project, you have optimized code, but you don't understand what's happening with it, especially Java. Java is like a mammoth of object-oriented programming. You were also mentioning primitives. And how does it combine? You being a Javist, and how does it happen that you don't use the standards of the language itself? Maybe I formulated it a little bit wrongly, but I hope you have understood me. Can you reformulate the question? Just a second. How? The object-oriented approach of Java combines with certain practices, optimization practices, where you're going away from this approach. And how often does it happen? Well, I've never seen a connection between object-oriented programming and optimization. So for the most part, object-oriented programming is about writing understandable code and optimization. There are lots of cases where you only have bits and bytes and you don't even understand what's happening. So I don't personally see any connection. So it's mostly about writing the code that people can understand. Okay, I got you. Thank you. Any more questions? My name is Genya. I would like to ask you. You were talking about the testing of RayList. Wasn't it a better way is to go into the documentation and to see where's the start of the array? Well, I understand it, but O of N in some implementation from one may be worse than O of N. So you can use some constant. The size of the array may be different. Well, the results will be different, so it's important to do measurement on production data, the sizes that are expected in real life, and you have some implementation. Instead of this array list, you can substitute a different list, take a look how it works, and most importantly, take a look at the difference with the help of a profiler, to see which methods have become hotter and which ones not. So, yes, of course, you need to write the documentation because everything is written there with the classes trade safe or not trade safe. But one can also say that quicksort is a logarithm of n, and insertion sort is logarithm squared. Nevertheless, insertion sort is still used, even though its complexity is quadratic. These are all synthetics. It's all about mathematics, and you have to look at the real-life data to make the right conclusion. So, dear friends, please don't be shy. Come to the microphone to ask your question. Hello, my name is Marwan. A question. Can you recommend how to motivate colleagues for code refactoring if, from their point of view, the code is readable and you don't like it? How to make them use but how to motivate them to do that? How to motivate them? Just, talking to them over a cup of tea and saying you want to become a real programmer. And again, if a person does want to become a better programmer, if they're eager about learning, but if they're not, nothing will help. I usually run a couple of presentations explaining how a good quality code should be written, and basically this presentation is like one of those. And then I see how people are writing, and then if something you come back to them and say, you remember how I explained it should be done, and then they correct themselves. So apart from motivation, you also need to do a bit of teaching, right? And I try to do that. I try to share my experience. Hello, my name is Alisher. Thank you for your presentation. It's very exciting. My question is, I'm basically from the .NET camp, so please don't throw things at me. So basically, whatever you said is applicable, everything is cool. The only thing that I'll have to take a look at multi-threadedness, because there are some differences. But my question is about something else. You said, well, your slide said that merge sorting is applied to the almost sorted arrays. How can we know if the array is prepared to select how to select the data? Here, my answer would be quite simple. Just open the source code of Java util.pivotquicksoft in my sorting, and then take a look how it's done in the code. Yes. Look at the source code. In any JDK, there's archive source.jar or zip, and there you will be able to see all the source code. If you have any questions to me, my email is in slide 1. Please write me. So you first check if it's sorted enough, and then we apply the sorting. Yes, of course, naturally. Yeah. Dear friends, we'll be able to take one more question.
Здравствуйте. Спасибо большое.
Hello. Thank you very much for your presentation.
Меня зовут Сергей.
My name is Sergey.
Спросить
I would like to ask
у программистов
the following. Programmers,
получается сделать
when they manage to do their job well,
нравится.
everybody likes that.
Рассказать из своего опыта,
Can you share
такой запоминающий
from your own experience some really memorable
задачу, которую вот вы выполнили,
problem that you solved?
не знаю, очень
And I don't know.
оптимизировали или
I mean, optimized something very well, and we're very happy. So it started working 1 billion times faster. You know, this is the question I always ask my candidates in interviews, hiring interviews. So, answering your question,
Я показывал,
in the first slide, I mentioned
система печати.
that the printing system was based on BinServ. This piece of code, this functionality, I wrote it once and sold it 3 times. I worked in other companies, and they had platforms. They didn't have printing, a good printing system. And I was taking my codes as a foundation and was even which I naturally remembered, had in my mind. I was improving it, and I was able to achieve a very good result. So this is an example. In programming, the rule of thumb is write once and sell 10 times. The last question again, Alisher. You started talking about your best code and what you're asking in hiring interviews. I also like asking the candidates, what's your biggest fuck-up? What can you remember, or what you were not able to implement as you had intended? Well, the time is limited. We'll meet separately because it's quite a long subject. But so I suggest we take one more question. Well, I'll be outside the room. Come to me and we'll discuss that. So, hello, Vladimir. My name is Alexander. Can you explain where's the fine line between the cleanness of the code and optimization, and which of these two is more important? Are there cases where in Sber they optimize the codes at the expense of cleanness? Well, talking about my code that I like very much, it's my sorting code. It's when you write code and you don't like it. It's like, for instance, you paint a picture and you don't quite like what you manage. Yes, it does work. It works correctly. And then you think through it again, you write it in a more elegant way, and it turns out to work, to run faster. I've noticed that there are times, there are cases where ugly code works slower, and the more elegant code runs faster. But whether it's elegant or ugly, it's only about your personal preference. I also have a brief question. Do you use a neural network in writing code? I don't. Yet, perhaps yet, I don't know.
Подсказок, но опять же, это подсказки такие на уровне
And again,
то, что идеи, да, бывает достаточно.
Sometimes you get some ideas, and that's enough.
Описание доклада сделать, я его как написал, оно
But like I have experience LLM improving my presentation.
И в момент, когда я проводил собеседование,
I like that. Also, I ran an interview, offered a problem. The person started to write code, and this artificial assistant started to offer its solutions, and then I could check. Thank you all for questions. So please use this QR code to leave feedback. And while we're not done, Vladimir, can you select the best question? The first 3 persons who asked the question, the last two, if they remember in which order, the first three and the last two.
Друзья, поднимите руку.
Dear friends, please raise your hand.
Сейчас Владимир вручит.
Please come here, and Vladimir will hand the gifts to you.
Владимир, благодарим тебя за доклад.
Vladimir, thank you for your presentation. Thank you very much. That was incredible. Dear friends, let's say goodbye to Vladimir with a round of applause. And I would like to remind you that tomorrow in the room across from us, in the Lovelace room, we'll have IT networking, which will include a stand-up.
А говоря о нетворкинге,
Vladimir.
Читать книжки.
So, who likes a book? Who would like a book? So tomorrow, 7 p.m. in Lovelace. And now we're going to have a 5-minute break, after which we'll continue talking about optimizations, but we'll switch to memory models.
Кто еще не был в нашем зале, мы продолжаем. И у нас уже готов новый спикер. Мы продолжим нашу тему и поговорим о эволюции.
We are to continue. We have a new speaker.
С нами представитель Mir Platform.
And
Это Александр.
we have Meet Platform representative. It's Alexander.
Как можно вообще работать?
And
Что менялось в их
he
истории?
will talk on how to work with memory and what has changed in its history.
Всем привет. Так,
Hello, everyone.
давайте тогда начнем. Меня зовут Александр Ланцов, я приветствую
Let's start. I am Alexander Lantsov.
модели памяти.
I will talk about
Знакомимся.
memory model evolution.
Так. Оп. Да. Давайте сначала познакомимся.
Let me introduce myself. I work in a MIR platform, which develops a MIR payment system, fast payment system. And you can learn about me, what I have done before. So we're going to look into many articles and examples. You can learn them on GitHub using this link. So, memory model, there are two words, but there is a lot of essence, a lot of meaning, depending on who is discussing. If you are a hardware developer, you would think about memory model in your architecture, x86. If you are an application developer, you would think about how the model memory is built into your language. If you are a hardcore system programmer, you have your own memory model and it works using your own rules. If you are doing in compilations, you would say that LLVM has its own memory model. And if you are a researcher, you would say that that is interesting. However, some academic work is more interesting. Thinking of new academic works trying to expand the meaning of this terminology. So, memory model, it depends on the context. Who is thinking about this? And the goal of this presentation is to answer why it's so complicated. So, in order to grasp this, let me make a plan. We would answer how everything has started. Everything started with hardware, when there was a multiprocessor system first appeared, and how the memory models appeared in software, in programming languages, because this was mainstream for Java and it has been improved later. We'll talk about academic works, why we're researching in this area, and what are they trying to find, people who are doing this. And at the end, you may think what to do after what we learned today, and I will try to answer this. So let's start where it all comes from. First, articles and multi-processor, multi-nucleus systems, and the mainstream systems. First multiprocessor appeared before. In the beginning of 1970s, there was a lot of systems that were made of several processors that were working at the same time. And all the developers, they had some problem. How developers could be granted guarantees if there are several processors, how to make the rules. Because you can make your own rules, but each time when you change hardware, you would have to make it from scratch. And then there is sequential consistency, also known as SC, a Lamport article of 1979, that if you have one processor, how to make of a multiprocessor system which works correctly. And this work has introduced sequential consistency, which has some difficult definition unless you understand it formally. So let me explain sequential consistency informally. If we have several executors, processors, or flows, and you say that only one executor works, one flow, it performs several number of operations, then you switch into a different flow and making operations from that flow. So at each time you have one flow working. Now we are in the hardware era, so I'm going to use terminology executor. And then I'm going to talk about flows. So example, what's the idea of sequential consistency? We have two fixed areas in the memory with their variables, A and B. And initially they had 0. First executor performs two commands, moving A and B variables, and then the second executor takes the value of A and B in R1 and R2 register. R2 equals 2 and R1 equals 0. That means the second executor has seen that we've written something in B and hasn't written something in A, although it was vice versa. And sequential consistency mental model says that in each moment of time, only one executor is working. So let's imagine a execution landscape. So let's suppose that A equals 1, and then B equals 2. Then we would go to the second executor flow, first reading B, and then reading BA variable. We can also have a different execution journey. It could be second command from the first, and then we perform the last command from the first variable. So what kind of executor we are using and what kind of command we are executing? This can be done combinatorily. We can also do smartly, first performing A equals 1, or to perform the B variable. Sequential consistency semantics is most convenient in the correctness of multi-flow programs. However, there is one problem. Sequential consistency is not free. What's the problem? In order to implement it effectively as to hardware, we need to violate this model as to the speed of processors and memory. So we need to weaken this model. And how can we weaken this model? We can do it differently. We can return from where we started, that each processor has its custom architecture, custom rules to work with multi-flows. But the researchers were able to answer this question. Article of 1990, weak ordering and new definition. It's sequential consistency, data race free. So if you don't have certain data rift, then it works in data race. Free. So it depends on how your code behaves as to different variants. So if there are no race, it's all good. So in order not to have race, hardware provides some magic operations, such as synchronization operations, as you know them, as barriers. So between different operations of different flows, you may guarantee that there is no race. And race is when you have two competing operations from where one is a recording. So if you cannot use it as primitive signalization,
не очень понятно как.
then everything works
С тем, чтобы писать свою программу.
unclear. But if you've written everything in order, then there is sequential consistency,
Это некоторые
a contract between software and hardware as to the data race free.
что если все делать по определенным правилам, все будет работать.
So if everything is done according to the rules, it would work well.
Широко известная архитектура сейчас это x86.
The most well-known architecture is x86. Some history in 1996 there was Pentium Pro, and although at that time there were no
Уже тогда можно было
nucleus systems, but even at that time you could collect a
Но что самое удивительное,
system.
что возможность для многопоточности у вас была, никакого описания.
There was an opportunity for multi-core system,
Году разработчики операционных систем, собственно,
and by 1996 there was a question: how can we use this?
все, что было, это некоторые объяснения в всяких там.
And there was an explanation on some forums and mail lists.
Чем он, наверное,
In 2005 there was Pentium D, which was quite cheap multi-core processor,
систему,
and when you can have multi-processor system.
более интересно,
But what's more interesting, only in 2007 there was first explanation how the
модель-то была, но разработчики Intel
memory model is structured into Intel. So the developers did not want to give too many guarantees, because if you give too many guarantees,
берете некоторые потенциальные
then you would remove some potential ways of optimizing your hardware. As I said, sequential consistency costs quite a lot, and even if you give strict model of memory, you would have to abide by it. So developers made quite a loose model, and that model was not correct. It does not reflect real hardware. There were some outcomes that were prohibited, and so this memory model was incorrect. And only in 2009 there was a formal specification which was fully correct, which has described how Intel works in case of races. And you see there is a big gap between potential programming in multi-processor system and specification, how it all works. A lot of time has passed. Let me describe some mental model. Mental model means we don't know how it works inside of the hardware, but there is a simplified model which outcomes are followed in this model. So we have a single memory, we have several cores, and each of them is making their own threads. So they are reading from the memory, so each thread reads a value from the memory using specific address. But when writing to memory, they would write to some buffer, which is called star buffer, and after some time they are getting into the main memory. And when processor reads from the memory, it turns first to the stack buffer 2, and such stack buffer is available for each processor. They have a consequence from recording. First example is passing, message passing. We have A and B variables. In A we have 1, in B we have 2, and in the other thread we were reading A, reading B, and then reading A. So if we have written something into B, we remember that we haven't written into A, but sequential consistency says it's impossible. x86 also says no. because we have only reading operation and writing operation. So if your value goes into star buffer and some star buffer gets into the memory, then all the values are also in the memory. So the answer is the same as in sequential consistency semantics. Another example where we can show the differences of sequential consistency from x86. We also have here a and b variables, but in the first thread we're writing A1 and then reading B, and in the other thread we do symmetrically opposite. We write B, we write 1 into B. So R2 and R1, can we see 0? Sequential consistency says no, because all operations. So first operation would be give 1 or 2 to B or A. And at x86, this is possible because using our mental model, each of the thread has made its record into store buffer, and there are zeros in those values. There is also ARM and there is PowerPC. I'm not going to go into the depths of the memory models. I'm just giving you some simplified diagrams how they behave. I'm going to show you an example that in those architecture outcomes are possible which were not possible at x86. The same message passing. We've written zeros into A and B. A is 1, B is 2, and reading them in reverse order. So in B something is written, in A something is not written, and then sequential consistency and x86 say no. But in Power and ARM, these outcomes are possible because you may not see these processes at x86. So if you are going to convert your programs from x86, the outcomes may appear since you've migrated to different architecture. And they have some coherency. Coherency means that all traces of one value which we see in the memory, they are done in a coherent global order. For example, coherency definition. So what's the idea of coherency? We have only one variable, x, with 0. We have 4 threads. In x we write 1, in second thread we write 2, and we're trying to answer the question whether this outcome is possible. It looks complicated. R11, R22, R32, R41. So the idea is that in the third thread we've written x1 and then 2, and in thread 4 it's 3 first and 4 second. So the answer, if we write it in assembler, the answer is no, because of this guarantee of coherency. Now we move to programming languages, because we're looking in the same coherency. Let's try the same example using not assembler but a different language such as Java. We are calling x variable, we're writing x1, x2, And then we are reading
исход, что мы увидели вот
them
X в разном порядке.
2 times in a row.
Что мы записали в X сначала.
So the third thread, we write first
что на архитектурах, если вот
3, then 4.
ассемблере, как есть ответ.
So if we write this in assembly, the answer is no.
Программирование, в котором есть какая-то
But in any programming language where there is multi-thread, it's possible.
гораздо шире и необычнее, чем то, что у нас
Because the functions are much wider than in hardware.
не можете, к сожалению,
So
архитектуру, которая у вас есть.
you cannot use the architecture which is available because memory model is much weaker than what is available in hardware. So we need to use the programming languages correctly. How they have appeared into the programming languages, the memory models. We have sequential consistency data race 3, which was first used for the hardware developers. There was a contract between hardware engineers and software.
Вообще-то им тоже нужен контракт, да? Им тоже нужен контракт.
So there should be a contract between software and hardware as we implement our programming language, compilers, and those that are going to use this, writing some programs and software for these programming languages. And sequential consistency principle for data race 3 is ideally suitable. So we have some synchronizing operations, not to specify the hardware, but to specify the language. So we're writing the program in such a way that there will be no race. And if there is no race, then the program behaves as to the model, memory model, sequentially consistent. It's the most simple model. So let's look into Java. In Java, there was a first attempt to make a memory model. It's quite interesting. As to the history, the first memory model has appeared into the first Java specification in 1986, and this principle has not been used yet. Although
оно подразумевало некоторый совсем другой смысл.
There is volatile.
Память не использовала принцип sequential consistency data race 3.
It hasn't used sequential consistency data race 3. There was no definition of synchronized operations definition. So volatile was a special word that they would make the most pressing value of this variable. So that was a feature. Any Java specialist knows this.
Для понимания. У нас есть переменная x, в которой мы изначально записали.
We have x value, we have written 0, and then we have a flag for volatile specifications. In one thread we write x definition and giving a flag. And then we read x in there is no happens before. So we have coherent reading of the record through volatile. And in the first memory model, since different variables were not given volatile, we could not guarantee that it would work. So that was a fatal flaw of first Java model, and it was corrected in 2004 when people understood that they should use sequential consistency data race 3, and they have determined specific synchronized operations such as reading, connection to the thread. Then when you use synchronized operations, there are no race. Using happens before. We have special semantic for final fields. And using happens before, we guarantee that there are no races. And everything works well. But since Java positions itself as a secure language, it tried to answer how the program would behave if we do have races in our program. So in Java, there is a semantic for race programs. And that's why there are all these problems with memory model in Java. There are a huge number of articles about it. So let me talk through, give you some examples from these articles. Let's look at this program. We have x equals 0. We have several threads. First thread, x equals 1. Second, x equals 2. Third is x we're reading twice. And let me ask a question, whether invariant R1 equals R2. Try to answer this question. Yes, the answer is simple. Of course, it's no, because these variables. First of all, there is no volatile specification because there is a lot of races. Even if it would have volatile specificator, we could not do the reading because the operations we would see in a different order. So the answer is simple, no. R1 does not equal R2. It does not guarantee this. So let's make our program more complex. Let's add intermediary operations in the third thread. We enter x, which equals R1, and then we make writing R2 equals x. So is R1 equals R2? Same problem. Even volatile specificator does not guarantee because the answer is no. So when we add some blockings on A and blockings on B in a different thread, so blockings are on different objects. We have third thread. We are taking blocking both for A and for B objects. So is it true that R1 equals R2? That is more complex question. The problem is that since we have blocking operations on two different objects in thread 2 and thread 3, they are competing and we have a race in our program, and Java determines semantic for programs with races. It's quite difficult to argue. So Java shows that it does not guarantee that R1 equals R2. It sounds strange because we've done some lockings, but no one can compete and change. But as to the memory model, R1 doesn't equal R2. So let's go back to our modified program, and let's take this intermediary operations, and x equals R1. So invariant, is it true R1 equals R1 equals R2? In this case, the answer is yes, R1 equals R2. So what's the biggest problem from the memory model? One of type of this optimization is in its name, that compiler uses records that are not needed. So compiler says, can I throw away x equals R1? So it looks like this is we can skip it.
Как будто бы с точки зрения здравого смысла так и надо.
And the
Базовая оптимизация.
common sense says that it's a basic optimization, but from the memory model, if we remove this record,
Исходов, которые возможно в нашей
then we move one array into the other array.
вариант, что R1 равно R2. Если мы эту строчку выкинем, то у нас вариант
And if we remove this
будет возможный исход.
line, we would have a possible outcome where R1 does not equal R2.
Как раз-таки находится
And all the other problems of Java are from here,
и в области определения вообще, насколько
with
реализация, которая у нас есть именно внутри JVM, совпадает с теоретической
programs with locks.
Вот еще один характерный пример. Ticket
A different example,
в чем
a ticket on OpenJDK. What's the idea? There is
вы можете
Power C, there is a formal model, and you can launch some formal verificator.
Так вот,
And if we take current realization,
верификаторе под формальной моделью, то она скажет, что те волатайлы, которые реализованы,
Then we'll say that those volatiles that have been implemented in OpenJDK, they're done incorrectly because they're not used
нам сделать запись в
correctly. So it makes the writing into volatile much harder. But in terms of reality, not a single PowerPC piece of hardware behaves exactly according to the description model. And in terms of reality, this operation makes no sense. So in terms of the memory model, we need to make writing into volatile memory hard, but in terms of practical experience, it's not going to fix the program. It'll just put it all in our performance.
В общем, как я говорил,
So as I said,
между тем, насколько
there's a problem between how the formal model is different from the one implemented in our Java machine. And there's another problem. In Java, there are intermediate semantics, var handles. They ruin the consistency in our race-free structure. So you'll make everything correctly, theoretically speaking, but the program will not behave according to the existing semantics.
Ну хорошо, мы поговорили про
Okay, we've discussed Java, but there are other languages, such as C++, for instance. Let's consider it. It got memory model in 2011. It's also depends on race, consistent dependency race-free, but you need to use it explicitly, std atomic. If you have a race not on atomic, then you have undefined behavior. Well, in theory, that could result in positive things. So you would be able to write some race detector. So actually, it's not as bad as one think. C++ has intermediate ordering. So it looks like what we have in Java. So using these orderings, you can order access to memory according to the model of this language. But unfortunately, C++ has the same problem as Java. There's another paper that I'm referring to. So what is the idea of this example? We have two variables, x and y. They're wrapped in atomic, they're regular integers. We have thread 1. This operation looks a little bit complex, but actually it's quite simple. We check the value of the variable x in relaxed ordering, and check if it's equal to unity or not. If it's equal to 1, we assign the value of 1 to the variable y. And we do the same thing in another thread. We read the value of the variable y in relaxed semantic, check if it's so, and then if so, we assign the value of 1. So is it possible that x would be equal to 1 and y would be equal to 1 as well? So it looks strange, but in fact, in terms of the C++ memory model, this outcome is quite well known.
Она вполне себе возможна.
So it's quite possible in the C++ memory model. You shouldn't have written anything in theory, but nevertheless it has been written. Okay, let's make our example a bit more complex. Let's modify our program. So we have the variable A, it doesn't have atomic, nothing like that. The second thread is exactly the same as in the previous example. We've checked the value of the variable Y. If Y equals unity, we assign X equals 1. Then in the second thread, we do it in the intermediate level. First, we check the value of the variable X. If it's equal to 1, then we check the value of A. And only if A is equal to 1, then we assign 1 to Y. And the third thread is just we assign 1 to A. Again, I'm not going to go into details, right? But it's shown in the paper that from the point of view of the C++ memory model, the only allowable outcome here is X equals 0 and Y equals 0. But there are all sorts of optimizations, some simple, some complex. I'll offer you an example of some exotic optimization because it'll just illustrate an example. In fact, real-life examples take more time, but nevertheless, let me show you this example. It's called sequentialization. We have two threads, and let's just execute thread 1 and then thread 2. Why not? Let's do this sequentialization of thread 1 and thread 2. That's we will pass the assignment of unity to A into thread 1. Unfortunately, this will make our problem into a situation similar to the first example, like out of thin air. So using some optimization, we'll have broken our program, which means that you can't apply this optimization in terms of common sense. You do want to do that. Same problems as in Java. We violate formally the memory model, but in reality, it just makes the system work faster. So one might think that these are old languages, and maybe they thought of some solution in the new language, such as Rust. What do you think? Well, Rust developers were aware of the memory model, so therefore they just said that Rust does not yet have a defined memory model. Everything is just as clean as in C++. You have atomics, and everything would work fine. Also, we have the concept of ownership, so there's only one owner of an object, so we shouldn't have any race conditions there. So everything looks quite well, but nevertheless, if you violate these rules, you'll still go bypass the borrow checker, and you'll make some competitive record via unsaved, and you'll get into the undefined behavior problem. There's also an interesting problematic. As you know, Rust is actively trying to be used in the Linux kernel. There are some certain things such as control dependencies there, and you get into an interesting situation. Rust doesn't have a formal memory model, but in addition to that, you need to make it so that its memory model should be friends with the memory model of the Linux kernel. Well, it would be interesting to see how they go out of this. Also, there's Golang. And in Golang, they just tell you, don't be clever. If you try to do something that's not available, just forget about it. Nevertheless, they have... Well, as to the race conditions, informally, they exist, and either that leads to stops the raise detector, or the read operation will return some value. But at least outer values are not allowed. Some compiling are not allowed. Compiler optimization method is not allowed. Out of thin air methods are not allowed. So that's why we're guaranteeing security, but at the expense of optimization potential. Also, developing the set there will be competition through coordination rather than via shared data. So an approach has been adopted that is quite different. So we've talked about some mainstream languages. We understood that all of them have some problems with the model memories. So let's talk about the development of memory models. As I said, in the current models, there are some similarities. They all use sequential data race free principle, but unfortunately, either they don't have guarantees in the case of race conditions, or if we do some races in Java, we have some problems with theory. More than that, in those languages that offer us guarantee in case of race conditions, these guarantees do not come for free. They are implemented at the expense of some optimization in your code. So it's all clear. But some people have not been happy about that. For instance, the author of this paper was not happy. What they were unhappy about in particular. They said, so if you've written the program correctly, then okay, everything's fine, everything was within classic semantics. But if you've run into a race condition, all your program is down. You need to think about it globally, and it's very hard. Let me show you several examples. Well, first, consider an example with C++. So you've opened code in IDE, and look what you're doing in your thread. You assign A plus 1 to B, and you see that there are no other operations with B or A. You would expect that a certain invariant is observed. For instance, B equals A plus 10, because we've done it just once, so we haven't changed anything, everything should work. It would seem this way, but if we have a race condition, everything behaves quite differently. Imagine we have a regular variable C, and we have another thread. So we assign 1 to C. And in addition to that, in thread 0, we assign A plus 10 to C. This is a different variable. It doesn't have direct relevance to A or B. And then the system says, we've calculated A plus 10 twice, so why would we do that? Let's replace and calculate A plus 10, and then assign this value, T, to C and B. And then it's only a short way to a disaster, because the compiler says, so okay, I assign B and you have T, so my register. So why do I not put B equals C? And then everything breaks down. We have written the value of C into B, and the invariant breaks apart. So we can say that we've hurt ourselves. We've created a race condition, and anything can happen. But this example is about something different. It's about you not being able to locally understand how your program will behave. Also, imagine we have class C that includes variable x, integer variable x, and so we do what's written on the slide. And it's guaranteed that we don't do anything anything with A. But what can we say about what's happening? We will have to say that A equals 42, because there are no other operations. But again, it's easily broken. How? Let's introduce an intermediate variable, another global variable,
не тот же самый, который...
that has a reference to another object, not the one that we defined in thread 0. And in another thread, we work with this global object. For instance, we assign the value of 7 to global X. And in the other thread, we work with the same variable. But the compiler decides to reorder these transactions because they're not connected to one another, and we get that our invariant breaks apart. So in the case of a race condition, in Java, we lose the ability to consider this. So the authors of this book decided they're not happy about that, and they decided to work in a different programming language, OCaml. It's a bit exotic, but nevertheless, it's used by some people, especially in the US. In OCaml, a global runtime lock existed for a long time, has existed. It's not an interpretable language, but they tried to get rid of the global runtime lock, which they did in 2022. How they did that? Just like in Java, they defined certain memory access operations, atomic and non-atomic, just like there are volatile and non-volatile operations in Java. And they decided to use the principle of local DRF. What's in it? What's it about? It's about the result of reading X not depending on their existing race condition on another variable. So what's another variable means? It's quite difficult to explain. It's about the OCaml memory model. But there are some corollaries there. So the reading in a single thread from A will return the same value if there's no competing record. There's no out of thin air. It's good, but unfortunately it doesn't come for free. It comes at the expense of banning certain operations, so optimizations, such as local store reordering. It affects the performance, but they ran the calculation on Camel, and they believed that it wasn't too important for them. So maybe there are some more exciting things, but of course we want everything immediately. So we come to this thing called promising semantics. It's being actively developed. Some new versions are being released. It's a formal operational model. It describes your program from the viewpoint of an abstract machine. The abstract machine is answering the question of which situations are possible. It's written in some modifiable programming language. So what do the authors want to do here? The authors want to build a model that doesn't have out of thin air, that don't have any restrictions for optimizations, and they want to make it so that you shouldn't get undefined behavior in race conditions. So one would think that this is the perfect situation, but unfortunately there's one but. This description, the description of this memory model in the abstract machine, I think that would be too heavy for an application developer. One should come up with something simpler so as it would be easier to write programs. So it's an academic work, but quite promising. Not quite promising in my opinion. So we've looked at the evolution of memory models. We started with hardware with the first papers and gradually moved to the programming languages. And then we arrived at the conclusion that it's with the formal memory models, most programming languages have some problems. And every programming language finds its own way how to solve these problems. So you should understand the approach adopted in your preferred programming language. If you don't do that, you may run into a situation that your program will stop working. Also, we've learned that race conditions are still a bad thing because, as you see, bugs happen everywhere. Bugs happen in the specification and the hardware implementations, in compilers, and we, as application developers, also write programs with bugs. So race conditions should be avoided. And the final thing, how to live on. One would think, what makes the bumblebee relevant here? How would you think?
Ну да, шмель просто
Oh, yes, yes.
была байка, что он
The
не может
bumblebee. There was this fable that the bumblebee can't theoretically fly, but they still fly because they don't know that they shouldn't be able to. Actually, it's indeed a fable. It's just that the early stage aerodynamic models could not explain how a bumblebee can fly, but later they developed the theory to the extent that it explained the theory why a bumblebee flies. So that brings me to the end. Thank you very much for your for your attention. Thank you very much, Sasha. Dear friends, please assess or evaluate this presentation using this QR code. And while you're doing that, I would like to talk a bit about your questions to Sasha. You won't have more than a few minutes for that, but for those who still have questions and don't have enough time, we suggest that you move to the lobby. And those who will have asked the best question of Sasha will get the book. Thank you very much. An excellent presentation. I have a question. Of all the languages that you considered, which one is perhaps the most deterministic execution trace, most best reproducible working with threads? Ordering everything as consistently as one. So actually, the answer is quite simple. Where you don't have multi-threaded things, then it works very well. Unfortunately, I won't be able to give you a positive answer because, as I've shown, every language has a problem, and every language has some potential approaches to solve it. There are other languages, such as Erlang, for instance. It works absolutely different. It's all about communication between messages, and it all depends on your energy, what you'll choose. As I've shown here, so guarantees against race conditions cost something, and that depends on you, what you want to use in your target project. Sasha, thank you for your presentation. I have two small questions. First, you showed a new model that's only being built in semantics. Has anybody already tried it in some popular programming languages? Maybe there are results, maybe something about overhead. Maybe you've already done something yourself in this one. So there are languages that use what? This new memory model that you showed, semantic, I mean. Well, it's academic. Unfortunately, there are no application languages. The freshest language for which we have some solutions, that's OCaml, it's local graph. Local semantic is still actively developed, is being actively developed because there are some theoretical approaches described there, but there's still a way to go for this to be usable in application development. And the last question, who lost the money? What's the reason for the presentation? Who lost the money? Why did you get the idea of making this report presentation? I've already run a certain number of presentations on multi-threadedness, and I just encountered the statement that academics say, so memory models are broken in Java, so we decided to, understand what it's all about. I have a couple of questions. Hello, thank you for your presentation. I'd like to ask you if you could take the microphone. Does it work okay now? Yeah, okay, good. Of late, a lot of attention has been paid to quantum computers, and I'd like to ask, how do you think the quantum computers, their memory models at the hardware level, are the same as for traditional software, or everything is much worse there because qubits, are more sophisticated than bits? It's a very creative question. Thank you. Look, when we're discussing memory models, everything is determined. There are programming languages that work to certain rules. The quantum world is, for me, there's no other such a thing as threads, because there are some computations made there on a quantum level, absolutely different. I'm not even sure if the memory models that we've discussed today are applicable to that one. I think that could be a very good idea for a presentation. Thank you.
И это будет последний вопрос.
Спасибо за доклад.
Thank you very much for your presentation. Exciting as always, but I would like to have some clarity on the following point. In all the main examples,
Глобальные переменные в разных потоках.
it was about working with a global variable in different threads. Nevertheless, there are situations where we can't predict the order of execution of these roads. When you get into a situation like this, saying unequivocally that we need to work with certain barriers, and that should be known and understood by the programmer. In that case, I'd like to have it clarified. You mentioned that one or the other, you know Erlang. Do you know other? And the subset, the Spark language, that is also about provable verifiability. You know, I've heard these names, these titles, but I haven't worked with them myself. Because because the language, there are some interesting models there. So I will familiarize. Thank you for your comment. I think that maybe we'll have the time to take the last question from this person. Hello, thank you for your presentation. My question is like this. Can modern statistic analyzers fully detect the presence of race conditions in the code?
Как дело обстоит?
And how about this in Python?
К сожалению, ответ на ваш вопрос.
Well, unfortunately, the answer to your question is more likely negative because there are indeed statistical analyzers that detect races. In Java, there's LinkCheck. Such some framework to verify data structures. But unfortunately, the answer is more negative because if your test fails, it means there's a problem. But if your test completes successfully, it's not a guarantee that everything's fine. So the test, the past test does not guarantee that you don't have race. So unfortunately, this is the way it works. Thank you very much for your questions. Sasha, now the most difficult question for you. Who you're going to award the girl that asked about quantum computer? I think that was an out-of-the-box question, so let's award the book to her. So please come to us, and thank you very much for your presentation. I'm hoping you'll join us with your presentations many more times in the future. And let me remind you what kind of other events we have at our PhD Fest. On the 23rd of May, Popov Room will have a fair of open source projects. And so far, for now, I suggest that we make a 5-minute break, and then we'll come back to you with the next presentation.
Всем привет! Мы продолжаем наш трек, и наши следующие спикеры...
Hello everyone, we continue our track. Our next speaker does not want any introduction.
Это то,
And the only thing that I can mention is that there will be two people representing the developers of national software for processors. So let me introduce them as wonderful people and let them introduce themselves.
Меня зовут Анастасия Черникова.
Мы работаем в компании Syntacore.
Anastasia Chernikova. We work in Syntacore. We do processor cores made in Russia. And I am in charge of compilators of developing, and we're going to talk about open source from its fundamentals and about the programs that you all know. So let me start, and I will give the floor to Anastasia later. So let me try to not to be in the way of the presentation. Who has heard about open architecture RISC-V? Alpha have not heard, and that's why I have two slides about this, because where open source starts, it starts when we make a system of commons, when we make architecture, and RISC-V is free and is open system of commons. So it means that at previous presentation there was a question. So if we do a system of commons ARM, do you know what is system of commons? So you are making this processor, and ARM then calls your license, as it happened to one large Russian manufacturer. And if instruction set is controlled by a vendor, it's like software which is controlled by a vendor. It's like Linux in the world of microprocessors, like OpenGL in the world of microprocessors, because RISC-V is controlled by the committee, which was established in 2015, this committee, and it numbers more than 4,000 companies that determine this set of instructions. In Russian, there is Russian RISC-V Alliance, and it's not only open, but also expandable instruction set. It means that you are choosing the basic instruction set according to your taste. After choosing basic instruction set, you can make any expansions, such as in a basic instruction set, you don't have multiplication, and it could be a small multi-controller. So you're making an M extension, and you add it, and every time when you make a hardware, you know, a stream, and there are hundreds and dozens of standardized extensions. So if you want to support quick photography and communicate this to people who are writing software, you are supporting ZKN, and all standard extensions are Z and then some letters. And if you would like to support some extension which is not standardized by the committee, such as Ghost Russian cryptography, which is called XK Ghost. You add this, and in your processor you support instructions which software can use for cryptography. And each solution, each standardized extension is open. So you can read it and everyone can use it, and it's quite convenient. If you want to have a quick cryptography, you can include a vector crypt. Sector core makes a line of cores. So you may see here a list, and at the top of each square there is a list of extensions from SCR1. So if you can disassemble your gas meter, which supports only R232M, up to SCR9, which supports a lot of extensions, compress instructions, atomics, and even vector extensions. So it's interesting that our open source starts from open command system, open instruction sets, and can the processor core be open source? It's a very interesting question, and I'll give the floor to Anastasia to cover this. Thank you, Konstantin. Before we go deep into the architecture, is it possible to have open processor cores? Initially, it sounds like science fiction, because processors are made by big corporations and they use commercial secret, patents, but open code became a standard in software. Why don't we apply this to hardware? If we have access to open architecture, which provides a lot of flexibility to us, we can design, we can change and adopt cores to our goals, which makes their manufacturing more efficient. Let's start with design. And on the right, you have how SCR1 looks like. Those that understand, not so many. So let's talk about one-tact processors. They're very simple. They perform all instruction in one tact. And such processors are not made any longer, they are not efficient due to how they are built and how they work with instructions. However, it describes how they work in those training problems. There are also multi-tact processors, how the instruction is loaded, executed, working with registers. And the advantage of multi-actor processors is that instructions are split into several acts, and they can work with a lot of memory. With one memory for instructions. There is also a conveyor processor when instructions are performed or executed at the same time. When one is loaded, the second is decoded, and third is at the execution stage. Then we split them in such a way in order to perform our instructions most efficiently. There is a conveyor process, instructions are split, and that's how we get the best performance. Such type processors are used everywhere, and you can take any device where the processors are of conveyor type. Example from David and Sarah Harris' book. The link is at the bottom, and you can see how at the conveyor processor there is a
мы сейчас в дальнейшем поговорим. Но удивительно, что
distribution
на данном
for
изображении
different
небольшое
processes
отклонение, и он работает некорректно.
for the pipeline. And
Для тех, кто интересуется
this
этой темой, разобраться, что же здесь не
may
так.
work
И
incorrectly.
книжки,
So the task is, the problem is, what is wrong here?
ответ.
So you can find the answer in that book.
И сейчас мы поговорим о стадиях непосредственно.
Now let's look at the conveyor stages.
Загрузка
First stage is
в данном
instruction
в данном процессе
fetch,
как раз таки чтение из памяти,
instruction fetch,
обновление нашего
and when it's reading from the memory, updating the program counter,
мы
and then there is a decoding stage when we decode opcodes, reading registers, and checking dependencies of our instructions. And then we are executing.
с блоком ALU, то есть с арифметикой.
We work with ALU, arithmetics, calculating addresses and conversion conditions.
Дальше идет блок памяти, то есть
Then there is a memory block,
как раз
access, reading and writing into memory, the longest block, and the last is writing into register, results processing, and instruction execution. SCR1 is example of this processor.
Код является открытым.
And this code is open code.
Загрузить, допустим,
You can download this
это работает.
and you can look how it works.
Базируется на 3
SCR1 is based on 32-bit RISC-V architecture, and it's ISO RV32I and RV32E. It also can be compressed, and it's used into microcontrollers and IoT, and in many training educational projects. SCR1 could have up to 4 stages of conveyors. The advantage is that the number of conveyors could be configured depending on specific tasks.
Мы в дальнейшем разберем подробнее, это интерфейс.
Interesting
Используется интерфейс IHB.
part is interface. It's HB and AXI interface, and also click interface. We discussed interfaces. It's important when designing any core and of what to make from the beginning. Interface is a system
компоненты процессора взаимодействовать между собой.
When processor components can interact.
У нас может быть взаимодействие непосредственно внутри.
So the interaction could be inside the core
ALU и регистровым файлом.
between ALU block and register file.
Взаимодействие.
And also using interface, there is interaction from outside of the core with memory or other periphery.
Большое преимущество интерфейса в том, что она является
A large advantage of the interface that it is a module. So having written this interface once, we can reuse these blocks, and this approach is clear for many developers from inside. So to develop interfaces, we need some methodology. How can we find information, how to write this correctly? And now let's talk about AXI and HB interfaces, which are most popular. And inside the core, there could be different interfaces, how we can configure them before launching. And in this case, I will talk about SCR1 core, which has both interfaces. So we can assemble them with one or the other interface depending on the tasks. Both interfaces have been developed in ARM, and AXI is an interface which is faster, more with high performance, but is more complex. It is simplifying many tasks, and but to verify, to understand that it works correctly is more difficult. HB is more simple, is older, has a simple design and simpler verification. An example of using cores SCR1 is Amur microcontroller. It uses SCR1
IHB интерфейс.
core
Контроллер часто используется для каких-то учебных проектов.
RV32IC architecture. It's used for training projects.
И вот сейчас мы все время разговаривали об одном и том же.
And
Но
we are talking talking about the same core SCR1, but there were
и вот
much more of them.
ядро IBEX.
One of the alternatives is IBEX core,
Low risk. И
which is developed by a low-risk company and is also available as open source on the market. This conveyor has 2 stages only. The architecture
как основную и интерфейс
LV32
TypeLink
and
используется.
its style link interface or HB. The main priority of creating this core was to work with devices which have battery charged and powered. So they are often using IBEX battery-based devices. It's quite a simple core. Here we have a more interesting variant, 6 conveyor stages, and principles are much more complex. 64-bit architecture, which is RV64GC as a priority, using AXI interface, which is much faster than HB from the previous option, and supporting Unix like systems. And we have developed a cache subsystem. So the there is yet room to improve. Black Parrot is a vendor. They've developed a core based on RV64GC. The advantage is that these are vendors that can work as a group. And here we have not one core, but several cores. You can see how many cores are in your laptop, and that is a big advantage. This Black Parrot can work as 4 cores together, and they are now improving to use more cores in one processor. So we discussed different cores, how they are designed from inside. But before making a model in hardware, we need to understand that everything works fine. It's designed correctly. For that, we need some test environment and test bench. It is also written around our code, around core architecture, and is made of different components. There is a memory model, some monitors, which monitors the system, how different parameters are changing.
И важно также, когда мы проектируем какие-то
And when we design some test benches, it's important to know that it would be clear to our colleagues that are writing the code together with us, and that it could be extensible code when we can test some part to the end, so that we could add some code and not to rewrite the whole code. For that, we need some methodology like UVM. UVM is a standard methodology to verify Verilog language systems. So we have DUTE, device under test. We have sequencer, which takes from somewhere the thread of tests, sending it to the driver, and this driver thread is sent to the device under test and sends this to the monitor, which monitors input and output data, and scoreboard, which compares the data as a etalon and the result of working with DUTE. how it works from inside.
О том, что необходимо тестировать наше оборудование.
So we need to test our equipment,
Откуда же нам, в принципе, взять тест?
see how it works. But where do we take the tests from? There should be a lot of tests, there should be of quality, and Konstantin will discuss about this.
Спасибо, Настя. Соответственно, рассказ Насти должен
Thank you, Nastya. There should be some intrigue from what Nastya said. It's so difficult, even if it's open source. If you need a full verification for these schematics, imagine complex interfaces. If there is a small bug in AXI interface, how long are you going to catch it? And you need to take a lot of tests. The first idea for tests is, of course, to take existing programs, like loading Linux core. If you don't have microcontrollers of Linux that are working on your core, you can load Linux core to test. So if you need to take something existing, you need to compile something existing first. And that leads us to the main thing which we do together with Nastya is open compilers. Compile infrastructure, LV. So let's try to compile and then generate tests without leaving open source. We are working on Syntaccord Toolkit, which is an open toolkit, which is freely distributed, and there will be a QR code at the end to download it, so you'll be able to download it at the end. Just remember that it's available. It includes lots, but it has some advantages. With GCC, there is a quite developed alternative. So that's why there is a connection of one toolchain to another toolchain by complex methods. And you can take Clang compiler and then assemble needed assembler to the required assemblers and use it as a necessary link. You can do this using GNU linked. This could be integrated if you have a root with GCC toolchain. There is sysroot is a special folder heading for applicable libraries. We can do that in LVM, and we can make some fine adjustment options for each core which supports our toolchain. Fine adjustment options, a compiler is very complex logic, and even machine-independent optimization unroll may impact code quality depending on the architecture. Because in one case, code size is important. You don't need to unroll much, and in some case, you have big instruction cache, and you may unroll infinitely. But I'd like to focus on a different thing. What we need now, it's a planning model. When Anastasia was talking about the phases of processor work, they are available on the slide. When you are writing a compiler, you are taking the same phases and you unroll it for the input instructions. And as for the scheduler, it is unrolled to minimize delays in the conveyor. So our technology is very much interacted. So LLVM is not only infrastructure compiler, but it's a universal source of architecture information. So we're using it now to solve testing of processors as a system verification. But why do we limit only with processor? Let's think about system verification, what we would like to verify. We're not starting from the processor. We're not launching something on the processor. First, we have a number of models, and even microprocessor could be perceived as a model. So let's look at the test generation for different levels of models. Functional models such as CAM, transactional model, cycle-based model, Gen5 or VCS, logical design on FPC, and how the tests look for each of these models. For example, if you have a functional model and you need to test logical design, how would you do that? Obviously, if you have a model and you would like to solve its verification, you need to check that this model satisfies specification which it generates. So verification task is to check specification. And if you have a working functional model but you are doubting its logical design, what would you do? You would generate a lot of tests and would apply them to model under test and golden model, whatever it is. But where would you take these instructions from? These instructions you would take from instruction sequence generator, which is part of the LVM ecosystem. And in that case, it's not upstreamed into LVM, but it's available on GitHub Syntaccord. It's called LVM Snippy, and let me elaborate on this, how to test it. It tests everything, where you need a stream of instructions. You can test functional simulators such as SPAL, Camel, and LVM. You can also test debug information to annotate it. So how this generator looks in the most simple case, using this GitHub link, you may download it, have a look whether it will be useful for your tasks, because we would like to build a big open source community around it. We have a generator which takes histogram with instructions. We are adding them, norming them to 1, and then we're getting this generation, we're getting the instruction sequence. But in the world there are millions of such generators. Why do we need to write another one? The thing is that LVM Snippy is a part of LVM, and there are a lot of things where many other generators that are available on the internet. It's taken from LVM Open System. It takes the instruction description and machine YARM, and inside that generator you can concentrate on generation logic, the management flow. So how this looks like. SNP is used for training processes, and Nastya has mentioned UVM methodology, which is still under development.
So if you write a runner that will integrate several snippets, run them, and include something like a trace, there are examples of positive use of this generator in open source. And we have an open LVM infrastructure. We've already seen that we can compile using it. We've seen that we can generate tests using it. And what else can we do with its help? You get an impression that we can do a lot of things, but let me pass the mic to Nastya so that she would tell you about the surprising things that we can do.
В целом экосистема
Thank you, Konstantin. So, on the whole, the LLVM system offers a huge set of different tools that allow you deal with very diverse situations. But today, we're going to talk about one more of those. So, it's a tool for benchmarking. Actually, the benchmarking tool is quite an important thing because it allows you to find bottlenecks in the system. Also, it helps sort out within the LVM ecosystem. The benchmarking task consists of different aspects. For instance, to verify how correctly the device works with memory, whether the information gets to the right caches, how interaction happens between different systems. And with this part, unfortunately, the tool that has been available is not going to help us. But if we have some instruction set and we need to know how long it will take for the instruction to run, or the throughput of this instruction, it's exactly in this case that LLVM exegesis can help us. So it's basically an LLVM tool that is distributed together with the compiler, and this tool generates an ELF file that either the tool itself or the file can automatically be run. So to understand the number of cycles needed for the instruction to be processed, or some other information. Let's talk about how it works in a nutshell. So at the input, an instruction or an instruction set arrives at LLVM exegesis, and then the tool generates a cycle that repeats the pattern that we're interested in many times over, for instance, 100,000 times. And then at the output, we get an ELF file that calls the JIT tool and runs the device so that the device gets this file and gets all the characteristics that we've asked. Or there's a more difficult way, a complex way that allows us running on other devices. For instance, we run it on our laptop, get a file or a binary file at the output, and together with test bench and wrapper, we're getting a complete program that we can run on another device and measure how many cycles are required to process a certain instruction, or the throughput. Just a second. So where and what for we need that? One of the ways to apply it is for different optimizations within the compiler. One of them is critical path optimization. To understand how it works, we take a program and build a weighted oriented graph. As weighted apexes, we'll take instructions for which, as weight, we assign the number of cycles to perform each instruction. The critical way is shown in the slide in red. This is the path that takes the longest. It defines the time of our program's operation, and our main task is to reduce it. And another way is to use it within scheduling models within LLVM. Konstantin has already mentioned them. And the slide shows a scheduling model for the Rocket processor. And it's clearly seen that dividing a 32-bit number, in one case you need 33 cycles, in another one 34 cycles. That will determine determine how the optimization will work. So this tool can help us. It was initially designed as a tool to build schedule models within an LLVM in a correct way. So we've talked about a lot of low-level components, how the hardware works, how the CPUs work, what kinds of CPUs exist. Then we discuss compilers and what sits next to compilers, the tools that help us develop the environment. But now, let's switch to the rest of the software and what happens above the level we've discussed. And it's Konstantin that's going to talk about that. So, imagine that you have taken an open core, have taken open tools, and loaded an open source operating system, Linux, or not yet loaded. For instance, you are designing a cellular phone to use another CPU rather than ARM. Are you going to run into some problems if you use the RISC-V architecture? Again, because in a certain sense, it's down to you to use RISC-V because it's open. You don't want to get into a vendor lock. Being a conscientious person, you should be interested in using open source operating systems. It's a surprise, but the main problem about RISC-V is exactly in where its advantages are. Look, Nastya was showing different open source cores with different sets of extension, and RISC-V kind of provokes you. It kind of tells you, make your own extension, build your own extension, get into an agreement with some Chinese producer, let them build a CPU with you for this extension, or take an open source core, and contract somebody to build an extension. So you've built it and produced it, and then a friend comes to you developing Android and asks you, look, what's the set of extensions I am to build my Android to? Or even worse, your friend comes to you developing glibc and asks, what's the set of extensions that I should rewrite glibc? And here you start feeling bad. It's an unexpected problem that exists in a situation where you have extensible instruction sets. It doesn't exist in the ARM world because when a development comes to them, under which should I discuss, should I build glibc? It's like asking what the political party were talking about in the Soviet Union. There was just one party, and these problems occur quite often in graphics APIs. Because with which extensions should I compile the program in GL? And this problem is solved with the help of profiles in RISC-V. When I said that RISC-V had a lot of extensions, I was, it was an understatement. There are very many, huge number of extensions. So this slide shows only the mandatory extension of RV64, RV822U64. It's a common profile in the standard of 2022. So we see that the number of only mandatory extensions, it takes a table of 4 columns, and there are 4 optional extensions. For instance, ZKN is exactly the cryptography that I was talking about, and V is just vector extensions. So you can have vector extensions, and then your phone will work much faster. At least it will do MEMCPA much faster. And so RISC-V plus profiles make RISC-V to a certain extent a normal operating system. It's at this moment that you need to understand that you'll have to write in bit root. So which configuration you should orient yourself at when you got the RISC-V hardware. And in a sense, the profile line gets better with time, and the software gets better with time. including the list of software that's available for RISC-V. And high-level software, if we roll back into 2010, at that time it was virtually in existence. In 2010, they were only designing the instruction set, and the first bare metal prototypes only appeared by the year 2017. But as early as in 2021, and I, for one, started to seriously working on RISC-V in 2021, I mean on RISC-V compilers. So as early as 2021, first Linux-capable hardware started appearing. The first
компиляторы для искусственного интеллекта,
compilers for AI started appearing.
Сейчас в 2000
Drivers started appearing in a large number, and now in 2024, 2025, RISC-V has developed to the extent where we have mobile server solutions, where we see vector extensions actively developing, including vector cryptography. For instance, LLVM now sees a huge growth of RISC-V vectoring commits, because RISC-V has a very interesting scalable vectorization. If somebody of you is not aware of how vectorization, how RISC-V vectorization is built, I strongly recommend you to delve into that. And a lot of processes. So this is the biggest selling point about the open architecture. Just imagine that something has been added to ARM. Well, I wish you luck. But if you want something added to RISC-V, more likely than not, some Chinese company has already done that. So this diversity, when open source code supports you from the very start to the final open source software, such as, for instance, when you run Chromium, that puts you into the world of open source software development. And the world of open source software and hardware development is the world where, as you work, the whole world is working with you. I strongly call on you. And actually, you can download this presentation using this QR code. You can leave your feedback on this QR code. It's also important for us. With this, we're done, and Nastya and I are happy to take your questions. Thank you all for your attention.
Да, можете называть номера слайдов, можете просто задавать.
Yeah, you can call the number of slides. Thank you very much for your presentation. It was exciting to listen. I got a few questions. You were talking about test instruction generators. I understand that these are just generators. It's supposed that they're going to be part of some test suite, right? Because a generator usually generates dust, and for a fully fledged test, you need to have a test framework that will verify if it is done correctly. I fully agree with you. We are talking about the instruction sequence generator, and it's exactly why I was showing that for it. Unfortunately, the clicker works rather slow here. But it needs to have some additions, and everything that is marked by blue is something you'll have to write it, because I believe in narrowly specialized software, generating a good instruction sequence, especially if it is supposed to have branches and memory, and you'll be able to configure which addresses it will fire to and which it won't, especially if the instructions are to be responding to that and snippet can done. So it's a very difficult task. So therefore, we've built it in such a way that it should fit with any wrapper. For instance, I left a question. The generator not only generates an ELF, but it also throws out a script. So that if you have some memory scheme, it should still be linkable. We try to do our best to make it integratable, and yes, all the users included in their own test benches, because it's what people doing verification do. Yes, clear. And perhaps these instructions have some cycles, have some loops, Well, I suggest that you listen to my other presentation, but we have a cycle counter, loop counter, and we book this register so that outside the cycle it shouldn't be used anymore. And in certain cases, we allow reading from this register. In some cases, we allow it to be reused if you've set the place in the stack for the generator. Because with compilable structure, the compiler can do these things almost for free. Thank you. Do you use this instruction generator to verify your own process and simulator? That's exactly why we wrote it. So it's not only to verify the tool chain, so verify the processor. How do you measure the completeness of testing, the coverage, and what's the test framework? Verifiers do that. I wouldn't even tell you had I known, more likely to know the secret, but luckily I don't even go into those details. Okay, thank you. But I still have one more question. You remember that old story when in the 1990s Intel released a set of Pentium CPUs and it had a bug in the CPU related to the divide instruction, and Intel had to partly recall this whole batch of Pentium CPUs. And after that, Intel started implementing formal verification when designing CPUs. A question, do you use formal verification in the design of the CPU? I love formal verification, but it's a very big question. It's a very complicated question. Let me be brief. In using formal verification, there's exactly one subtle point that I've been highlighting in this room 2 presentations earlier. When the presenter was talking about SNT solvers, you run this thing that proves you that something is never going to happen, and then you don't know. So you're waiting, for instance, 30 hours, whether to press Control-C or wait another hour. So is it ever going to stop? So we use formal verification in a limited way. For instance, formal verification to a certain extent in certain specific areas of symbolic execution using the CLI system, they can be used to select the data, and then you can load it into the generator, so the generator should supply it with database data for this instruction. We even have a commit on review in the snippet like that connects to the database. And by the way, it was built by students from St. Petersburg University. It's a very exciting area, but it's very complicated. A formal verification of a small node is okay, but formal verification of something large is unexpectedly difficult. It's super hard. When you were talking about Control-C, perhaps you meant model checking. The biggest problem of model checking is that you have an explosion of states when you have to model too many states, and the model can take an infinite amount of time. But there are alternative ways when you have a model and run against it and compare the model of your CPU and the Fodl model. You're using reductive verification. Do you use approaches like that? You know what? I have not taken part if they use, but that's a subject that's a lot of interest to me. I dig it all the time. So there's direct task. We generate more tests and see what happens. And there's a reverse problem. We start with a situation and try to prove that it will never happen. There's a SNP generator solves the direct problem, and I would sometimes like to write something that will solve the reverse problem, but I don't have a solution so far. It's just you're saying that formal verification is very difficult, but at the same time, we all know that the system can show the presence of bugs, but does not prove their absence. I agree with that. There are a lot of statements there, and it may take a lot of time to wait. Thank you very much.
Там есть вот сотовой микрофон, может, по очереди?
Maybe we take a question from that mic. Hello. In the beginning of your presentation, you mentioned an interesting idea that RISC-V is just like Linux in operating system. And I would like to highlight a certain risk that an unpleasant incident happened in this foundation when this cancel culture touched upon Russian developers. They threw them out, stopped taking commits, taking contributions. So how about this in your case? What risk do you see? And what happens if the risk realizes and you're cut away from the chain? Well, why? What if? It has happened, and what? Nothing changed. Nobody is going to ban the development of user specifications. So we have limited ability to impact the international specification, but we can keep developing the specifications for the Russian lines. So just imagine everybody was banned from Linux, and then everybody switched to Astra Linux. So you can still develop the specification in Astra Linux. More importantly, you can continue using everything that has been developed worldwide. So you got into a fork situation. No, we haven't. We do our extensions, but a lot of other vendors that haven't been banned anywhere also built their own extensions. Everyone has a right to build extensions. It's just you can't contribute to the committee. And how do you synchronize the stories that LVM got features for others, but will not include your own? Well, we have the Syntacore development toolkit that I've shown in the slide, and which is the main things that we're working on with Nastya. It's so it's not going to appear in the main corpus, but it's going to appear here. If you have Syntacore cores, you can include this. Hello. Thank you very much for your presentation. I was lucky enough to work with one of your cores with SCR1 as part of my research. And perhaps my question will seem a bit naive to you. How realistic it is at the level of the design of the software core to design the security of this core, or to implement some the security checks at the level of verifying this core. Nastya, would you like to answer? Yes, please. Can I have the clicker? One of the cores we were talking about. The previous one. So on the whole, there are open source open cores that focus on security. Of those listed, perhaps this one is the most secure one, but one can take a closer look. There are cases in the open community, and it's right in the documentation where it said that focus is made on security of these things. So it really exists, and it keeps developing. Thank you.
Давайте успеем еще два.
I think we have time for two more questions, and then we'll switch to the next presentation. Thank you very much for your presentation. I have a question about your answer to one of the previous questions. You use the phrase that you use click as a tool for symbol analysis, and you use it together with a form of verification. So how do you determine that CLI, that it makes sense to run CLI on some specific piece of code, on some specific set of instructions, to understand that it makes sense to run CLI on this set of instructions? That's easy. We run it against the entire F extension, and we don't use CLI. We use CLI-F. St. Petersburg development on top. Students will soon be defending a diploma work right this summer. It's very easy. We take instructions one by one, then we take IBM and use this model to search. What kind of instructions? All of them? All of them.
Анекдот рассказать на эту тему.
And I can give you a joke about that.
Полный набор.
A student took the full set of instructions for FE, the ECU parameter, 1 second, for FMO, 1 second, fuse, multiply, add, a day and a half. We almost pressed Control C. So, yes, that's exactly what I meant. Thank you. Good evening. Thank you for your presentation. I have two questions. Number one, do you approach the protection of power attacks?
Соответственно, это вопросы к
Power supply attacks. These are questions to physical design, as I understand, because a side injections on the power is not even about logical design. It's just like how the heat is distributed between lanes. Yeah, but it can impact the pipeline as well. The pipeline.
Я еще раз, скорее всего, вы будете
Once again, perhaps you'll be observing this impact at the level of physical design. I never went there. I start with logical design. I understand it more than not, but all these things, when heat is generated, so the fan is rotating, and some conclusions are made. I don't know that, but what I know is that there are people in the company who perfectly understand this. They're not here. Why they're not here? There's nothing open source there. So open source ends in logical design, and then you get into the realm of, hard secrets. Okay, thank you. Question 2. You had it in your presentation when you had a collapse with Micron, with Amor, 32 was created. Are you planning to collab with themselves or Melandra or some other Russian producers once again, but to deep a bit better into IOTA, as it's important to see in IOTA is responsible for security. So there, it must make sense to foresee some security mechanisms related to the update of firmware, the hardware level. Why hasn't everybody laughed in the room? It's a great joke that the letter S in IoT is responsible for security. It's not present there. Look, regarding collabs, as I said, SCR1 is an open source core. The vendor can just download it. They don't even need to buy it from us. They can download it from GitHub and then do whatever they want. Yes, so they build a cool Amor microcontroller. And by the way, Nasya didn't say, it was printed in Russia at the Micron fab. So, can anything else be done for IoT focus on security? Yes, of course they can. You can. Well, the question is not that abstract, whether they can or not. The capabilities, of course, are there. But I'm interested in specifics. Are there any plans? Well, had I even known about such plans, I wouldn't have the right to publicly disclose them. That would be something like commercial secret. Again, thankfully, I'm head of compiler development and I'm not aware of the hardware product development. Maybe you should find some marketing people at the booth. Unfortunately, we don't have a Center Core booth at this conference, but maybe at some other conference. Thank you all for your questions. Nastya, Kostya, it's time for you to choose the one who will get the book from Peter Publishing House. Which question did you like the most?
Давайте сделаем ребятам чуть проще.
Let's do it this way.
Вопросы поднимите,
The
пожалуйста.
guys who are asking these questions, please raise your hands. Nastya, which question did you like the best? you like best?
Думаю, что вопрос про СНИПи.
I think it's the question about the snippet. Let's stop there. Okay, yeah. So you're welcome. Our assistants will hand you the great book from Peter.
Давайте поаплодируем
So let's give a round of hand to the guys. In first place, thank you very much for your awesome presentation. That was incredible. And with this, the first day of our conference runs to an end, comes to a close. Thank you all very much. We'll be expecting to see you tomorrow online and on the site. Thank you, all of you.